Hello everyone, welcome to the Builder's Workshop. My name is Nathan, otherwise known as Old Man Builds. Gerald will be with us shortly. Guys, I wanted to show you a couple of cool things that we did with that Tesla coil that we built last week. So I'm going to go ahead and share my screen here and show you some of the cool experiments that I did today. So this right here is one of the little things in Sean's kit that he sent to me last week or a week ago. And basically, it's a bunch of lights that go with that little mini Tesla coil thing. And you can see they light up brilliantly. So I'm going to pop through a couple of them so we can take a look. Sorry. There you see we just got a little bit of breakout, but it looks like a spoon in this one. Oh, that was just the resonance frequency there. And here we go with the video. Just showing how much the light goes out. Now, this is my other Tesla coil here, the one that's actually in resonance. So as you can see, we have no problem getting 3 feet out of this. I can actually get it to 5, almost 6 feet when this thing is really going. And that's just at 40 volts. So as long as you're in resonance, you can see how bright it is. Man, this thing is just unbelievably awesome. So let's take a look. We got some other things on this, man. It's just, it's unreal what this thing does. You can see we got breakout. This is the first time I got real breakout with this coil. Right now we're at 30 volts. And I always check the MOSFET, or excuse me, the transistor. I always get the two going there. We're about 80 degrees right now, 78, 80 degrees. So we're staying cool, but you can see the breakout already happening. So right about there is 3 feet. Let me go back just a hair. I want to show you that breakout on this. That's not bad for a transistor and a resistor. As you can see, it's way out there right there. You see, now it takes a little contact from my hand to keep it lit right there. But right there, man, we are pushing quite a bit of distance in this thing. So it's pretty cool. Check the degrees again. This thing really doesn't get too hot. We can keep it under 130. We should be good. The manufacturer says 140 on it, and I believe them. We got it up there with 40 volts at that. And there's nothing I could do until I change the circuit. So I wanted to leave it pure for this right here, but you can see how bright it is. This thing, it's unbelievable. So you can see that's our circuit right there. That's it. There's a little transistor. I just got a heat sink on it, and there's a resistor in there. So we built it last week. So it's pretty cool. So here I am. I'm putting lights around. Just lean that one up over there. But it'll light up your garage for you a little bit. Just with 40 volts, nothing big. But you can see it's really cool. And again, that's a transistor and a resistor. 47K ohm resistor, one transistor. So I thought that was pretty awesome. I'm going to show you a couple of things more. Yeah, there's a big fat guy, Nathan, walking around. All right, let's see if I can get to the next one. So I did a test on it just to see what the climbing is. So you can see right here we're at 81. 20 volts. So we're not too bad. And that's the breakout you get right there. So we'll just turn it up a little bit and see exactly where we go from here. And we'll just check the temperature one more time. Again, we're not getting too hot. We're in the 90s, so it's climbing a little bit with it. But notice how it jumps a little bit. That's just not a shaky hand. That's just kind of what the transistor is going through. So there's probably some leveling needed. But we're getting a decent breakout right there. So we're going to push for 40 volts here. We had, what, 30 on the last one? So let's see what we get. Now, this is about as far as I pushed it. And I want to blow up the circuit and find out, trust me. But with those temperatures right there, that's pretty much the end of that. I could probably get for a few seconds just a little bit more. But that's about it. So that's 40 volts. And we got a nice breakout at 40 volts. So I thought that was pretty cool. Kind of give you a little bit of a guideline on how that thing goes. Oh, you don't want to see this. This is just me winding something. Let me see if we got something else. There you go. Let's take a look at those. These are the things Sean sent me with that kit. I can't zoom in anymore or else I would. But as you can see, these just light up beautifully. Yeah, that's really cool, man. I thank you, Sean, for this. This was really awesome. Oh, I can't believe people put these things on their skin. That's unreal. I can't believe they sell stuff like that. I do like it for the lights, though. It's a brilliant color. Yeah, 32 gauge wire on that coil, 11 inches tall. Sean and I came up with it. It's a 4-inch tube, just a piece of PVC from the lumber yard. So, yeah, look at that. That's like a little spoon. It's so cool. These things lighten up. And this is at low voltage, just right here, probably about 20 volts. We're not even into the voltage yet. That one only lights up real bright when you get all of the voltage into it. So we hit a sweet spot right there. That's for sure. Anyway, it's pretty cool what this thing does. Yeah, look at that. Just one or two or flips between them. And they get brighter too. So I'll let it go a little bit and we'll go ahead and watch this thing get a little brighter. When you see it in person, these things aren't straight lines. They have little UFO type shapes going like this. Like boom, 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 all the way down. But when you get them on camera, they look like a straight line. And if I had a better camera, I would be able to show you that. But it's still pretty cool. Even the breakout looks more brilliant. Look at that. Just like a spoon. So cool. These things are like the neatest things to play with. I could do this probably all day. By the way, my computer, usually the lights are green. They all turned plasma purple and stayed there. I had to reset my computer. I was pushing this thing like distances out, and my table sits right next to my computer. So maybe I should move it away next time. But it was pretty cool. Let's see. Let's turn this sucker up. I had the clip fall off right here. That's on there. I didn't permanently put it on because I was going back and forth between Tesla coils testing them, because I'm trying to get the resonance of my red one behind it to be the same as this so that I can light them all up at once. So I was playing with it. Then I had to put this thing back together so I could do this. So, all right. Oh my God, you have a 6 foot wound copper. He's going to try. I would love to see that, by the way, when you get that up and going. Yeah, take a look. This thing's beautiful, man. Lights up. Looks like a comb. Probably put it in my hair and I'd probably go balding some more. Oh, man. Yeah, I love these things, man. There's like a dead spot. You can see it right there, by the way. I don't know if you noticed that. Let me just take it back just a bit. There's dead spots in the Tesla coil when you actually wind it. So you'll find spots that look like that in places, and then spots where it doesn't light up all the way. So this is actually a great tool checking your field and seeing where it is, because there's going to be some dead spots in it. I thought that was pretty cool. So anyway, guys, that's the Tesla coil right there. Gerald says he's got a lot of circuits coming, so we're kind of waiting on him. I don't know when he's going to get here. Hopefully soon. But that was kind of what's going on. So yeah. And I'll show you the transistor for that circuit real quick while we're looking at it. Yeah, give me 1 second. Here we go. There it is. Oh, man. I did it again. Okay, give me 1 second. I'll pull it right up. There it is. So this thing right here, you can see in it. Let me make sure it shows up. Yeah. We have current can take max 15 amps, 230 volts, but the temperature is what gets you. So the max says 130, but we're well over that. And I think we were in Fahrenheit. This is in Celsius. So, but we were hitting some pretty good temperatures on that thing. So I don't think it has much more to give. I wanted it to give a lot more in resonance, but that one didn't want to give it. And the crazy thing is, let me stop sharing the screen here. As soon as you started to use the energy, as soon as the breakout happened, the amount of distance went down. So the more ability you have to not have that breakout, the further distance you get with the Tesla coil and the lights. But as soon as it starts to turn on, you're going to lose about a foot worth of distance in that whole Tesla coil because it's breaking out, because you're using the energy. So you just want to radiate the energy. So I have a trick to do that, and I'll do that with this another time. I just stick something down the center of the Tesla coil, and it'll start pulling the energy. So it won't allow it to spark. So it's pretty cool. Hey, Ben, how's it going, man? Nice to see you out there. That's why you need big heat sinks. Yeah. You know what? I could probably get the temperature down a bit more with a bigger heat sink. You're probably right. Let's see. We could use lower temp using a magnetic refrigeration. Yeah, it could. It all depends on how fast it's heating up, but you're absolutely right. We can cool it down. Let's see. You can lower the hertz. Yeah, I can actually add a circuit to this and change some of that. But I wanted to keep it with the original circuit that I showed last week. That way we just had a simple follow-up. You know what I mean? This is what it's doing when you connect it in correct resonance, because my first coil was not in resonance at all. It wasn't even close. So it just barely oscillated. This one oscillates perfectly every time. So phototherapy device, high frequency. Oh, yeah. Yeah, that's what it is. What? Face, chin, neck hair. I was going to say, go for your hair. Man, that'd be trick. Probably burn all my hair off, or whatever's left of it. Huh. Hello, how you doing out there, guys? Thank you very much. Yeah, we're just getting started, but usually, man, we have a good old fun time on these shows, man. Huh. Yep. So, well, Gerald just says he can't make the live. His car broke down in the middle of rush hour, so he's not going to be here. I guess we're not going to be doing circuits. So, guys, if you want to join me, jump on in. Ben and Crypto, if you're out there. Just sorry about that, guys. Yeah, can't win them all, I guess. Yeah, I wish you was here too, man. Ben said he might be able to come on in a few minutes. Oh, we could do something else. We could do something else. Yeah, it does happen. Oh, well. All right, Gerald. Hopefully you're all right out there, and hopefully you get in safe. Anyway. Yeah, we could start. I guess I could just turn this thing on real quick if you guys want. So give me 1 second. I'll just fire this bad boy up. All right, we're already good. Let's get our camera set up. Yeah, right next to the computer. That's about where it goes. Man, who doesn't want a Tesla coil right next to your computer? So let's pray nothing goes bad. I'm going to hit this thing as a little bit higher and see if we can't jump it up a little bit. See if we can't get that spark to go up. Goes right up to 50 volts. That's so cool. I don't think it can sustain at that. Look at the light bulb in the back, though. It's just it's already lit up. That's so great. Oh, man. You got to love Tesla coils. Let's see. Hold on. Oh, let me grab these. We'll turn it up just a bit. That's about what we're getting out of it. That right there is about 10 inches away. And this one lights up. It's starting to warm up now. Oh, it looks like it's glowing in my hand. That's so cool. Look at that. All right, that one's starting to warm up. Let's try another one. There we go. You know what? Maybe I can get the camera just a little bit closer. Let me try. Give me 1 second. All right, that's max. That's about what I could push it at. I don't have any more distance there. Looks like an eye right there in the center. Sorry for the shakiness, guys. I'm holding it because it's pushing the wire to the limit. That's so cool. Let's see if we can't get the plasma right behind it. So let's go to the next one. This one goes a little further away right there. We're at least like 14 inches right there away from the Tesla coil. Oh, there we went. Looks like that from a Tron show back in the 80s, man, where it just looks like bright, like neon. That's cool. All right. Ooh, he likes to grab it. Look at that. Ooh, I might have burned it out. Maybe that's not good. Ooh, it's red hot. Ooh, that thing is red hot. Let's not do that again. Sorry, Sean. Old man Bill likes to blow stuff up. I have to buy me another one of those. Look at that. The Tesla coil comb. Just what I need. That thing's getting red hot too. Look at that. Wonder if that other one burned up the gases. I hope not. No, that one's dead. I think I burned that one out. Well, that's what you get when you experiment, I guess. Oh, let's play with some more light bulbs. Let's just have some fun. Nice. Nothing but fun, guys. As you guys can probably tell, this thing's going to last a while. This thing is running right now just under 40 volts. And it's going to last all day if we want, probably. But you can see these things light up pretty bright. That's so awesome, guys. So let me get this thing face back around to me. But you got to love Tesla coil fun, man. When you get them right, you get them right. They just work. By the way, that Tesla coil would never find resonance without Sean. So Sean, thank you again. So he helped me build that coil, telling me what's going on. And we built that. The circuit's something that another YouTuber told me about. And we went ahead and built that. This thing is just awesome. I absolutely love this stuff, man. Once you get there, Myke, always play with high voltage. Thank you. Yeah, I'm working on it. Nice. So yeah, guys, we got a lot of stuff. It's pretty cool. Yeah, Bernie's there in the background. What's up, Crypto? So yeah, we're definitely getting this thing going with these circuits, these Tesla coils. Now, I was hoping Gerald would be here. I wanted to disconnect the circuit in a little bit, and I just wanted to show how it worked first. I have two coils that I wound. So I'll go ahead and show the winding video so that you guys see it. And that way you understand what I'm doing here. Now, by no means am I an expert winder. I just did whatever I could. So what we're trying to achieve in this one is it's a triangle, but it's a play on triangle. So 180 reverse. So as soon as I wrap the first triangle, I then have to wrap the opposite. So we're making the star. And there are exactly 7 open spaces in between every time. And that's 20 gauge wire that we're using right there. So you can see now it makes a star. So now I'm going to start a second star. So it's just in a progression. Now, I don't know if this is the way Gerald does anything, but I thought this was pretty cool. So this is the way I did it. And you'll lose your mind if you don't recognize where the star is every time that you do the wrap. So I didn't do this by numbers, guys. I know a lot of people have a number sheet when they do this stuff. I just memorized part of it, and that's how I wind it. But that's just me. That's just the way I work on it. So, but as you can see, we're going into our next star. Now we got to cross it, which is always fun because you have to get them right. And this stuff, it likes to come off the ends. It likes to mess with you. Right there, I'm having a total brain freeze, trying to figure out exactly where I was. Yeah. Basically, we have 24 screws is what it is. And that's on a 250 millimeter winding or round shape, the diameter of it. So you can kind of configure what it is there. I usually build these things in my head, or lay them out on the computer, and then I wind it out. So I should have wrote it down. I would have went much faster, but I don't know. I don't like reading notes even when I write them. So I just go with the flow and see if it works. Yeah, no, geometry doesn't mess with me. Math doesn't mess with me. Sometimes you get lost. Like I said, this thing likes to trick you because you think that you're in one triangle, but then you got to flip it opposite. So it's not an easy progression. You have to remember which one you're in. And then when you forget, you have to wind it back in your head. Then you can get it again. And that's it. And if you mess it up and miss one, it sucks. And these little tabs, they always come off the little tabs. You can see me right there. I know I'm not hitting the right one, and I'm looking at it. And I know I've already done that wind, and I'll find it here in a minute. But one of the tricks to this is anytime you wind triangles, you play a little game. You cannot hit the center. Anything that crosses over the center, you're out. So every time I wind, that's the way I got to think of it. But then you got to think of a triangle being the opposite, not the next in the progression. So one triangle, then the opposite, then you move one in the progression, then one triangle, then the opposite, then you move one in the progression. That's why you see me over there playing with it. Yeah, I got lost. Yeah, you're right. I should have wrote it down. It happens, man. So I'll get it again in a second. Once I do, I'll go pretty quick. Get the rest of it, get done. Yeah, circular music scale, absolutely. So, like I said, one of the things that I wanted to do with this was set it up to my Tesla coil circuit here. I got two of these, and they're both bad. I missed one wrap in both, and I just wanted to see by doing that, did I get them resonant to each other? Yeah, you see, you constantly got to push this stuff down. It's a pain. And that's it. So I only wound one for you guys today. I just wanted to show you that. It was kind of a neat thing to get it around and make those star patterns. Here, I'll rewind it 1 second so you can see what we're looking for. You see the first one, which is pretty easy. And then we go in and out until we get to the second one. Now it's got to make the star before you can go on. And get my arms out of the way. And then it's got to dial one progression. So I made the star there. I move over one. And it's always 7 blank spaces in between each one when you go to wind it on the triangle in order to get this pattern. So as you can see, there's one star and they're starting a second one. As soon as you put that second one in, man, it starts to get a little confusing. So you really have to watch what you're doing. I should have taken some clearer shots of this, that's for sure. But we'll go back. There you see, we almost got the star right there. I finish it. But yeah, it's not exactly the easiest wine in the world. So we'll find out. We'll find out if that's the way Gerald did it. I doubt it. I'm sure he's got some better method than I do. But that's just kind of how I got it going there. Yeah. You know, what I did create, by the way, and I didn't put it in here. Let me see if I can't pull that up for you. Because I did create a pattern to go underneath it to keep out the confusion. So I'll see if I can't pull it up on my 3D printer setup right now. Give me just a second. I'm pulling up Fusion 360 for you so you guys could see what I was looking at. So yeah, it's getting there. Everything has a wind and a flow, so it's kind of hard to figure out your flow before you put voltage in the first one. And I've built this a couple times and trying to figure it out. So yeah, those awesome logos, man. All right, let me see if this thing's unloading. Let's see if I saved it. No, it doesn't look like I saved it. Wow. Yeah, wasn't that a mistake on my part? Oh, well. Let's see if I got it in a 3D print, though. I might have it. Oh, Oh, here we go. It's already up. That's why I couldn't open it. Well, that figures. Okay. This is the one I want. Sorry it's taking so long, guys. Just a second. Yeah, I found it, so it's sure. All right, so this is the pattern I came up with. So basically what you're looking at is there are two different heights on each side of the triangle. And where that goes is inside the circular pattern that I use to wind it on. And you turn it each time you do a progression. That way you can never forget where you're at. Now, I didn't have time to print this off today. I was on grandpa duty yesterday and watching my granddaughter, and I didn't have time to do everything. But this right here is exactly what you want to do. Print something like this off, and then all you want to do is rotate this. So every time that you do it, you just want to turn it one over or wherever you start your next progression. That way you can remember to follow each triangle. So hopefully that helps you guys out when you do this kind of stuff. When I get the thing right, I'll leave the STLs in the description for this video, or if I make a video separate, I'll do it there. But that way you guys get to see what's going on here. What do you think, Ben?
Sorry, I'm just getting my camera fixed.
Oh, yeah.
It looks amazing. I'm really interested. I really want to try to wind one of these complicated flat wired coils. I do think that they're going to produce some really unique effects for sure. Look, that's a pentagram, right?
Well, yeah, it's yes.
Oh,
Wait, go
all
ahead.
right, my headset's not connected. One second. You might get some feedback.
Oh yeah. Yeah, so simple and complex at once. Yeah, it really is. It's like it'll drive you nuts. That's why I created this part here for the center, because sometimes you get lost in where you are and you forget the one you're on. But at least this way you can trace it back a little bit and find it faster. So, and then by the way, if you don't create that bottom piece, what sucks is that these things like to mess with you. So it'll keep coming off the peg. It'll start messing with you. You cannot take it out and just put zip ties on it, because then all the tension's gone. So what I did was I built a negative and a positive of the outside piece, so that I can just drop a secondary piece like a sandwich over top and then hold it in. So there'll be two sides to this. So once you're done winding, boom, you pull the screws out, you pop the top on, and it's set, man. It stays exactly the right tension and everything. So it'll be something to do, that's for sure. Maybe I should have started with an easier one.
No, you would think starting with an easier one, but honestly, I'd say start with one that you're passionate about. Because when you have that passion driving you, it doesn't matter how frustrated you're going to get with winding it, you're going to find a way to do it. You're going to find that method. I really like this. This is cool.
Yeah, you just said like in the center of it, the hexagon. So there's multiple different geometries at play. Every time I've done one of these in a different wind, there's always two geometries to it. There's the one you think you're winding, and there's the one that shows up.
Right. That's crazy. Yeah, because I don't know. It's hard to visualize what that's going to look like in 3 dimensions as a field, but I don't know. Maybe there's a piece of software that we can use to help us visualize like these different shapes, these different geometries.
Well, think about it this way. So it's this shape and then progressed. So you just move it over one. So it's stair stepping. So if you think about it, it's one shape, turn it just a little bit, it's stair stepped, finish the shape, stair step it again, finish the shape, stair step it again. It's like a winding staircase going up.
Right.
So see if I have the other one, I'll show you.
I don't know why my backgrounds aren't working, but I just put this one on. My internet's acting funny. Oh, I do have the coil, the fireball wound, because I was doing, like you said, recording the video. And what we're going to do is for the class, I am going to start it at 9 a little later. And because we're doing, I pre-recorded some videos, and this will be a better system, because I'll play the videos and explain how to do everything. And then everybody will, go do their coil and work on that part. And I'll be there to answer questions and to help, and I'll be free. I won't have my hands tied, and
there you go.
It'll just work out better that way.
Yeah, I agree with you. So
but I do have the coil if you want to see it at some point.
Yeah, as soon as I'm done describing this, let's check it out. So this right here is just this is the bottom piece that goes on your table.
Oh, so this is the part that you're winding with. This is like your frame.
So you just put a screw in there, and I like to put a straw with the screw in case the winding goes up, it doesn't tear up the thing on the screw, the wire on it.
Right, yeah, because it'll scratch it.
Yeah. So there's a positive and a negative to this. So what I mean by that is there's another piece that sits right on top of this. So it sandwiches it. It has little pegs, and they go in the little holes right there, and the round piece goes on there. So it just makes the sandwich on it. So
once you're done winding it, you can close it up.
Yep, that's correct. So that it always stays with the correct tension on it, and it never changes.
Right. No, that's smart. And you know, as many of these as I've seen, I've never seen a cap like that. I've never seen anybody try to cap it off.
Yeah.
That's a good idea.
Well, because they always have to take it off their table and they use hot glue or, I mean, something like that. I mean, eventually it'll have to be dipped in resin, but I like the frames. I like to be able to just pop it on there.
Yeah, you can put a nice transparent window in there and see what's going on and give it a nice, you know, artistic style.
Not only that, if you want to start stacking them as a capacitor.
Oh, yeah.
Now they're in that little frame. So now all I got to do is to put some plexiglass in between, and I got a capacitor of these two plates.
Oh, my God. That's brilliant.
So, yeah, it kind of changes the game, doesn't it?
Adds a whole new aspect to these circular coils here. Wow. This is a game changer for sure.
Yeah, we're going to have some fun. I'll be ready when Gerald's ready to go on that, man, because I'm prepping, building files, getting stuff ready.
Right.
So,
you see how just slightly tweaking the manufacturing process can extremely deliver, you know?
Well, and when we put the patterns in there, and you can see the pattern through the windings, you know what I mean?
Yeah.
And then as I turn it, I'm cheating. So go ahead.
I'm sorry, go ahead.
I was just going to say, instead of remembering the numbers, I just turn the dial underneath.
Oh.
That's about how easy it gets. I'm making it easy.
What's the pattern to wind for that? You have like a clock pattern where you like start at like 9 o'clock and then go to like 6 o'clock, or?
So you have to mathematically figure out where your star is first. Okay. So in this, you can't see it in that one. I'll have to show you in the other one. Let me pull it up. When you pull up your, oh man, where's the video at? There it is. So sorry, give me 1 second. And here we go. I'm getting slow today. So you see it, right? Now watch. We're just going to count 7 over because mathematically that's going to give me a triangle.
Right.
So from 7 spots are open. On the 8th one, we're turning. So you can see we're starting to get our triangle. I followed the same pattern all the way around. And then when you're done, it makes a perfect triangle, right?
Right.
Sorry, my hands are in the way.
And then you wind it on the 8th one.
Yeah, and then we have to move once we get back to the original spot, right? We then have to maneuver it up. I think it's missing 3, and then hit the 4th one, and then turn. And then you'll see it start to make the star pattern. You see it right now?
Yeah.
So that's how you have to do it. And then when you're done with this, you have to go 1 over. That's what makes it so difficult. Now, you see I'm starting the 1 over now?
Is this all the same wire, or did you start a new wire?
No, it's all the same wire.
All the same. Okay.
So you got a big spool next to you, and you're just winding it off of it. So you can see I went 1 over, right? And then now I'm starting a whole new star. That's where it starts to get confusing because now you have wires that look like they're crossing everywhere.
Right.
So,
yeah, and you have to really pay attention or like, I don't know, put a sticker on one that you started, while you're working maybe. I don't know.
Well, that's what that little star dial was.
Oh, okay. Okay, yeah.
I don't have it in here right now. I was just doing it out of my head. But when you do that, you just shift it 1, and that keeps your place.
Yeah, it keeps track. Exactly. No, that's cool. It's built into no, I like that. That's really neat. Yeah, no, exactly. You need some way to keep track, and just keeping your hand on it. As much as you try, you're gonna move your hand sometimes and mess up.
Oh no. Just get a scrap piece of wood, screw it into the table, and then maneuver it every time. Hey, you know what I mean? The center's open. You're not going in the center with any wires, so just put the screws there.
Yeah.
Anyway,
cool.
It makes it so much easier because you have to keep tension on this. It's enough to worry about already. Why not make it easier?
So I'd be interested in seeing this also as a bifiler, or maybe, doing 2 halves and then putting them together.
Yeah.
That would be cool. I don't know if that was your intention at some point, but that just popped in my head.
Well, I have 2 of them that I wound.
Mm.
Neither one of them are perfect, but they're at least 4 layers deep. And what I wanted to do was hook it up to my Tesla coil circuit.
Mm-hmm.
And I want to see if I can't get them to resonate. Now, since it's forced resonation, then I don't know. Forced resonance, sorry. I don't know if it's going to work. Okay. I'm sure it's probably going to turn on, but I may blow that transistor right out of the water.
Mm.
So I wanted to run my Tesla coil first so I could show that to everybody. And then I'm going to hook those up while you're doing some stuff today. I was going to do it when Gerald was there, but I want to see if I can't get the light bulb to still light up.
Hmm.
And go ahead.
Yeah, no, go ahead. You said you wanted to see if it light up.
Yeah, I'm just going to wire it up to a Tesla coil circuit.
Nice. I mean,
And
while you're doing that, we can do some experiments with our Tesla coil or, work on a simple circuit of some kind. I know I've got a couple of things to show you guys with the Fireball, a little preview for Sunday.
Oh, right on. Well, show us. Let's take a look at this thing. Let me stop sharing and you can start putting it up.
Right back.
Yeah, I'll grab those real quick as soon as he comes back. We'll see if we can't get them. I'll just get my soldering iron over here. All right, let's take a look at this.
So
right,
this is the Fireball.
Let me show you. Oh, you got red winding in there too, huh? That looks nice.
Yeah. So
it
did. I will have to rewire it, simply because we did come up like a foot short on ending the final wind, and that's my fault. I used a wheel measurer, like a measurement with a wheel, the wheel measurement utility, and I instead of like going over the root, I kind of like probably hit the root with the wheel, and it spun it probably a foot more than it was. So I was reading as 50, it was probably like 49, right? So that was my fault. I do have enough wire though. Yeah. So it's gonna be, it's the thing is, when I was working on it a couple of days ago, I live in an apartment complex, and the area is kind of a bad area. And I left the power drill out in the back for a few minutes, and I came back and somebody stole it. So I'm gonna have to get another one. Until I do, I won't be able to rewire this bad boy. But as you can see, it's pretty straight, but there are a couple of slight bends. And I don't want to straighten it out at this point because I'm just going to take it apart and redo it, right? It's slightly short. And this wire bundle actually came out slightly thinner than the other wire bundle, even though it's the same gauge wire. I think it has to do with the thickness of the enamel. We'll see.
Nice. Yeah, that's so cool.
It turned out really nice, Nathan. I like this orange, and with the fire red, it really is a fireball,
Yeah, that's cool.
And it's huge. This is going to be a really good driver coil for driving magnetic rotaries, and also for using as a main driver for our pickup coils.
You got your little cup there, Ben?
The what?
The cup with the little ball magnet. I want to see how it fits inside the center of that coil.
Oh yeah. I also have a new. I got a ball bearing too. It's not magnetic, but we'll see what happens to it. Like it is. What do you call it? Paramagnetic, where it will be attracted to magnetic materials, but it doesn't attract anything itself.
Nice.
It's a little bit smaller too.
What's going on, Mike Faraday? Nice to see you. We're all doing some fun stuff today.
All right, so here's the neodymium sphere and a little bearing, a little ball bearing I found.
There's a sphere. Nice.
This one is the neodymium sphere. This is the smaller one. So,
and One of them's just metal.
Yeah.
Nice.
So I'm gonna put that, and I'll demonstrate how it'll fit. So this will fit quite nicely. And as you can see, since it's a lot bigger, we'll probably be able to get this to spin and levitate inside the middle here finally.
Nice.
Hopefully, I'm hoping. And we'll have 2 extra wires, full 24 instead of 22, so we'll have a little bit of extra field strength.
Oh, that's so cool. Well, you know what? It's also cool that you found that ball, because now if you take 2 cups to each other, you can get the magnets to go one on top of the other.
Mm-hmm.
And then you can see if it actually spins.
Yes. You can keep track of the orientation and all that. And then with this one, since I mean, look at how thin the wire bundle turned out to be compared to the openings. I don't know if you can see that, but there's plenty of space there for more wire. So I'm thinking when I do this over, I might just add like 32 if I have enough wire, you know?
So what was the gauge? What was the gauge you used, Ben?
24.
Nice. So you could have put 20 gauge in there and been just fine.
Or I'm sorry, yeah, I'm thinking the opposite. Yeah, 20 gauge. Go down is a little thicker. So I was thinking I was in my head it was backwards. But yeah, going down a little bit thicker, I could use 20 gauge, or I could just do more wire. You know, like instead of 24 channels, I could do like 26 or 28, something like that.
Right on.
Yeah, and that should give us a lot more field strength. So if I think I have enough wire to do that when if I can get another electric drill in time for Sunday, we should be able to.
Would you do me a favor, Ben? Would you pull up Mike Faraday's thing and send him an invite?
Yes.
He asked,
yes.
and I can't find his email right now.
I got it. No. You take care of the stream, and I'll take care of that.
Right on. That coil looks awesome, man. I can't wait till he starts getting it going on his machine.
I know. And this way I'll be able to test it, you know, during class while people are working on their stuff and, you know, asking me questions and, you know, if anybody shows up. I hope somebody shows up.
Oh, we're all going to show up. We're going to crash your stream again.
You're gonna crash.
You know how that works.
You're going to raid me?
Always come by and check on you. See how things are going. I
appreciate that. I get lonely over there in my corner of the internet.
I'm there with you, brother. Some days.
Oh, we have a new Patreon member, Charles Milligan. Thank you for your Patreon donation. I will get that sticker over to you. We're in the process of making them now, so give me a day or two, and I'll get you your Patreon sticker.
Oh, right on.
Yeah,
congrats, man.
Awesome. Yeah, we set up a Patreon just, you know, to help out, you know, research and funding and all that stuff, and because it really does help out, and people have been, you know, like helping out, and it makes a difference, you know, it really does. But yeah, if you guys are interested, I have a Patreon, you know, different tiers and benefits, but you can discover that on your own.
you get a bunch of money together and buy some cool stuff with it and show some experiments. You gotta love that.
I just want to have the proper funds to do the experiments that I want to do, you know, and some of these experiments require expensive like stuff.
Oh, they do. Trust me.
But you know, I got all the basics, and that's good. I got 2 Arduino kits. I got a whole bunch of, you know, like tools and basic stuff already. There's a couple of things I need. I need an oscilloscope, like a proper one, maybe a little bit bigger of a workbench power supply. I'm not sure. That one's kind of small.
Oh, well, how many volts does it go up to? Like 40, 30?
Yeah, something like that.
That might be enough for what you're doing, to be honest with you.
Right, as long as I have that trigger circuit to keep it from going back in.
There you go.
Yeah, no, I'm going to order that this week. I'm going to order the trigger circuit, and then there's another part off of Amazon that was really cheap that Mike recommended. And then the transistors, and I think that's all I'll need to order for the Bedini phase 2 testing, because this coil right here is going to be for phase 2. This is why I wanted to do another coil. I wanted to do it properly for phase 2. I wanted it to look nice, you know, presentable, and because I don't just plan on demonstrating it live. I want to go around, you know, and demonstrating it in person too. People need to see stuff like that work, and I like doing it. You know, I like showing people this stuff.
Absolutely. So you got to do it.
I wanted to go and present mine at the Cosmic Summit this year, but unfortunately I couldn't make it. Otherwise, I would have brought my coil up there and just, you know, like hung out in the parking lot and say, "Hey guys, want to check something out?" Like a creepy, you know, the creepy guy. "Hey guys, want to check something out?"
Don't be that
guy. I'm gonna show you med trick.
Oh, you're going too far now. Oh, you're funny, man. Oh, yeah.
No, I was watching Beetlejuice yesterday, man. They came out with a sequel, and I'm all excited about it.
Oh, really?
Yeah.
Right on. You know, Merkaba sent me some stuff too. I was just trying to find it right now. He he sent out a video today. Oh, let me see if I can't find it.
Oh, I'd love to watch that.
Yeah, he's describing his device a little better for us.
Yeah, all the videos that, like, anything that you show me, I love his videos. Everything, every time you show me something new, it's all exciting. Last time he had a new containment unit for his like neodymium sphere that looked all professional and stuff.
Oh yeah, he's got this thing going, man.
I think the only thing he needs for that containment unit is just a little window so you can see it.
Yeah, that'd be cool. Or just do some clear plastic.
Yeah.
There's some what is it? Some resin. What do they call it? Resin printing? And then it comes in really super clear.
Oh, cool.
So
this is his generator, right? This device right here.
So I'm gonna turn the volume up and play it.
Oh, nice.
The 6 copper-colored coils that you can see are connected individually of the Merkaba generator. The 6 copper-colored coils that you can see are connected individually to a 6-channel selector box, featuring a series of mechanically operated switches, each isolating a respective audio input. The switches are designed to be switched in succession, allowing for sequential routing of the individual audio signals to a common output, which then feeds into an audio amplifier. The coils colored red, green, and blue are wrapped around the star in an octahedral formation. They are powered from the output of the audio amplifier. These coils are connected in series and are all wound in the same direction. They provide the electromagnetic field that drives the spinning of the magnet at the machine's core. The containment design is currently an 80mm 3-part cube. The bottom section has inserted into it a 20mm flat sapphire crystal watch glass, below which is a copper powder resin pellet. The middle section is a cylindrical design with a 3D printed PET-G carbon fiber lining. All 3 parts of the core are fastened with nylon bolts to the 6 supports. These are tipped at the ends with custom-made silicone rubber shock absorbers. The signal generated by the magnet itself spinning is picked up by the 6 small coils. The faster the magnet hears itself spinning, the faster it wants to spin. I assume because it is trapped in an audio feedback loop.
It's creating a resonance cascade where it's just amplifying it and just increasing exponentially. That's crazy. Hey, what's this guy's YouTube? I don't think I'm subscribed to him.
Let me go ahead and copy it and I'll put it in the description real quick.
Yeah, we all need to blow up his YouTube. Let's all subscribe to his YouTube. This guy is awesome.
Yeah, I talk to Merkaba about it every day, man. He's got some cool stuff going on. Let me tell you that right now.
I've never seen anything like this, Nathan. And it really it baffled me at first, but this video kind of explains a little more. I mean, it's so like unique. It's so different. I've never seen anything like it. It's so cool.
Well, he was wanting the same circuits that Gerald's building and that he was going to give to you because he's running on an amplifier as well.
Oh, okay. Yeah, he's just using a stereo amp receiver.
Yeah, so that protection thing is what he was looking for as well. Hey, Mike, you made it. All right, let me pull him up. Sorry about all the confusion, Mike.
My bad. I didn't even get a chance to email him. Did you email him?
Well, I put it in the chat, and then I found his email, and I put it to him.
Okay, yeah, because I was in the process and I started talking. I got distracted. What's
How you
going on,
doing,
Mike?
Mike?
Not too much, just hanging out. Saw you guys doing a live stream, and I figure, hey, why not?
Yeah, come on in.
Yeah,
So
we're
how's
just hanging
everything
out.
going? Did you build your plate for your battery?
That's in the works right now. I'm waiting for materials again. It's like I was saying before, if these materials are getting harder and harder to get, and they're taking longer and longer to get.
That sucks,
So
man. I hate waiting for materials.
now Trudeau screwed up stuff again. He's putting a huge tariff on all the EV cars being manufactured
boy.
or imported into Canada.
Uh-huh.
So now China wants to retaliate by cutting off all our canola oil. We're the largest canola oil producer in the world, and they want to cut us off.
Yeah, it's a
So
cascading effect, huh?
yeah,
That
it's
sucks.
now Trudeau apparently the new Democratic Party of Canada is now pulled their support of the Liberals. So we could be seeing a federal election in probably the early next year. So looks like Trudeau could be on the way out, which is good.
That's good. I don't like him personally,
Gotta
but
see
I
my
mean,
shirt. See my shirt?
oh, nice. It's a
Made in
Canadian make.
Canada. It says "Made in Canada."
Nice.
Love it. I want one. Dude, Canada's on the top of our list.
Don't wear a "Made in Canada" in the U.S. You might get shot.
Oh, no. Well, no, Canada's one of the top destinations we plan on going. So I'm gonna go to Canada. I'll wear it when I visit.
I actually, not to boast at all, but I looked up the latest census on the top rated places to live in the world. Canada's ranked number 3 in the world.
Nice. I love it.
So it's Switzerland, Norway, and then us for standard of living, cost of living, jobs, just overall. It had a whole bunch of criteria, but we're ranked number 3.
And also, you're ranked number 1 in cool people because we got a bunch of cool people from Canada, including you.
Right.
And Gerald.
Yeah.
The U.S. unfortunately is ranked 42.
Oh, that's fun.
It's not. I was shocked how low it was. I'm like, whoa, that's really low.
It's pretty low on the list.
Like, wow.
It doesn't seem that way with our border going crazy right now. It seems like we're number 1 when they all flow in.
You know what? I can't be biased about it because I've been to New York City, I've been to Buffalo, I've been to California, San Francisco. Every place I went to was really, really good. Actually, my favorite was LA. It reminds me the most. LA reminds me the most of like it is here in a lot of aspects. The shopping and the quality of the streets and the overall lifestyle is very close to the way it is here. New York, on the other hand, is not so good. I've been to Manhattan. I've been to Queens. I've been to Roosevelt, which is a pretty rough area. That's right in off of Manhattan. So, you get your good and bad places, I guess. You wouldn't catch me in Chicago. You wouldn't catch me in Detroit. Unfortunately, it's just the crime's too bad. But, we got problems here too, like any other country. We got our shootings, we got our murders, and we had some brainiac decide to drive his car over a police car with his Jeep. Today. It made headline news. I'm like, it doesn't surprise me because of where it happened. Yes, one town that's very close to where I live is notorious for crazy crap when it comes to automobiles. The worst driving on the planet. They have the highest car insurance in all of Canada. Just to
Wow.
give you an example, I lived in that town for about 2 years. 2 years too long. My car insurance there would have been $4,500 a year. I got a
$4,500 a
100
year.
year. Okay, perfect driving record. No speeding tickets. Nothing. Clean record.
F
Based on
that, man.
yeah.
F
Based on
that.
know how much I'm
Sorry.
paying. No, it's true. It's the worst in Canada. So I'm paying now just over 2,000 a year where I live
Yeah,
now.
that's expensive. I wouldn't be able to
Yeah.
do that's not sustainable for me.
Oh no, who can afford that?
You know what? I'm gonna start selling rodent coil insurance. That's what I'm gonna.
Yeah. Oh yeah.
I'm kidding.
Yes. And even
It's a joke, everybody.
even the city of Toronto too. You're looking at about $4,000 a year to insure a car. So a lot of young kids
Yeah.
now, they're coming out and they're like, holy cow, like especially the young ones, right? Their insurance is super, super high. So yeah, if you live in a good area, be happy you do. Right?
Yeah, I mean, I'm stable where I'm at, but I'm not in a good area by any means. Like I showed up one day to my apartment
What's
complex, and there was like 5 cops in the cul-de-sac of my apartment, and there's this dude supposedly, I guess, running around with a gun, and they're like, "Oh, lock your doors. There's a guy with a gun. We're trying to get him." I'm like, "Oh crap!" I come home from work to this.
What state are you in? What state are you
I'm
in?
in Michigan.
Oh, you're in Michigan, so you're not that far from me.
And I do work in Detroit sometimes, so I know how it is. I mean, I love Detroit. It's an awesome city, but it is dangerous.
Yeah,
you gotta be careful, gotta be safe.
Yeah, same with Chicago too. It's a nice city, but it's got its issues, like really bad.
The people are, the people I talk to, a lot of them are cool, but at the same time, there's, it's you gotta watch your back in places like that.
Yeah, it's
be
just
careful.
street smarts, right?
Yeah, and that unfortunately comes with experience. You can't just like automatically be born with that knowledge. You got to
But
trial
you
and
know what?
error and make a couple mistakes.
You know what? This day
Lose a
and
wallet
age,
or two.
like this day and age, I wouldn't allow my daughter to go play in the yard, by herself. No, it's not going to happen. It's a different world. Like when we were kids, back in the 80s, you could go to the park all day by yourself. You didn't have to worry about having a parent around,
Right.
But today, no, it doesn't happen.
Yeah, and things, especially with the social media and the internet age, information flows so fast and it's so easy to get information, So if you have nefarious motives, people have a tool to utilize for that, and you got to watch your back. and the thing is, like, things aren't stagnant. The world changes, and in life is about adaptation. But this idea that we can go back to like the good old days, I think the universe is always pushing forward.
Yeah.
And change is necessary for the progress of our spiritual development, whether we like that change or not, I guess,
So
even though I would like to, I do have nostalgia,
Well, to kind of keep on topic with the free energy and, what we're doing, I was doing experiments with the transducers, and I was actually putting them up to my forehead and my temples. And I was doing frequencies. So actually a transducer, and just using a regular signal generator. So anyways, for the job I had to go for a medical, and they did a hearing test. So anyways, they put me in, the box, the closed box, and they give you a little trigger, and you put a headset on like this, and they start doing the tones, and they start doing the tests. Every time you hear a tone, you press the trigger. So anyways, they do the test. It takes about 15 minutes, give or take. So I see the lady outside, the nurse, and she's looking at the thing, and she's going, no, like this. She's shaking her head, right? And I'm thinking to myself, uh-oh, I'm in trouble. Like this, right? So anyway, she opens up the door and she goes, sir, come outside. Let's take a look at your test results here. She goes, I don't know. I just found the results here kind of very peculiar, like this. And I go, peculiar. And she goes, she goes, okay, your left ear at 2 kilohertz, 3 kilohertz, 4 kilohertz. Your left ear is nominal. It's performing normal. So, anyways, she goes on your right ear. For some reason, at 3 kilohertz, your ear loses a little bit of, acuteness. But when you got into the 4 kilohertz range, your hearing enhanced. It got better. She goes, this is impossible. She goes, no.
Could it be maybe a mistake with the testing equipment, or?
Well, this is what she's saying. She goes, these results that you got on your right ear is impossible. Your hearing actually should have got worse at 4 kilohertz.
Right.
Right? Because of the frequency, it went higher frequency. And then I thought back, I got a flashback, and I go, oh man, I was doing those experiments with the transducers. And I was playing around with the frequency ranges, right?
Mm-hmm.
So she goes, okay, you're going back in the box. So she throws me back, she threw me back into the box again and did the test again. Did the test, comes out, and she's scratching her head like this. She's going, no, this can't be right. She goes, you got the same result, but almost even better with the 4 kilohertz range. She goes, I've never seen this before.
So what range is that? Just for reference, like, is that like an out of range for humans, or?
That's getting into the animal range, say like a dog.
Right. That's what I was thinking.
Right. So my right ear is enhanced at a high frequency, where my left ear is running at a normal 3.
So theoretically, you might be able to hear a dog whistle.
Range, which the average human hears correctly. Hertz, but it got better at 4 kilohertz. Which was just totally, she was floored. She couldn't believe it. She goes, I've never seen this. This is impossible. So meanwhile, I'm thinking, oh man, those transducers, maybe they did work.
Yeah, you don't know what these effects are going to be, when you're using them. They blow stuff up, they sometimes have interference with other devices. There's all sorts of stuff going on.
But you got a frequency and you got that transducer that penetrates your head. So did the transducer have some effect on my inner ear on the right side to make it more sensitive?
Was it powering a load while you had it up?
No.
Was it powering an LED or?
No, It was just hooked directly up to my head, and then I had it on my temples. I tried it on different spots on my head, but I found
no medical.
Okay.
We're not allowed to do anything with coils and medical.
Oh, okay.
Yeah, that
was weird.
No.
So, okay, let's switch the subject.
Yeah, sorry about that. The coil that he has there, is that the same one that you were showing us? Because that's hard to see.
Oh, sorry.
The circular one?
I'm trying to hook it up as a Tesla coil. I rewired my circuit to the coil right here to the one I wound earlier, and I'm trying to see if I can't get them to resonate together.
Have you ever dabbled with transducers, Nathan?
No, I haven't. No.
I wonder what the effects would be with your Tesla coil with some transducers as a pickup. So say you have your Tesla coil, and then you got a pickup Tesla coil on the other side, okay? And then you hook it up to a full-weight bridge rectifier. You step it down. So the second Tesla coil, you would invert it upside down. get that voltage down as much as you can, maybe like one winding, hook it up to a full wave bridge rectifier, and then hook it up to, say, like a capacitor or something that it could dump into a light with the transducer, and see if a frequency can actually be generated with the transducer on the pickup coil. Like, you don't have to have them too far apart, maybe 6-8 inches apart from each other. Because I know with transducers, if you hook them up in parallel with a coil, it enhances the reactance. And that's how my Renegade works, my Renegade generator. So, like, I had profound difference in the amount of reactance coming off the coil with the transducer in parallel. That's why I've been using them ever since. Every pulse motor I build now has at least 2 transducers in parallel with the coil. It really, really enhances reactance.
Nice. I'm gonna have to do that. So I may have to put a load on this thing in order to pull it.
Yeah, just hook up a low wattage LED, like a 4-watt LED bulb, just enough, and you can put a DC capacitor, say like a 10,000 microfarad, 20 volt or whatever. And what will happen? It'll fill up the capacitor. When it has no more room, it will surge and it'll dump into that light. It'll be a ballast, so you don't blow things up. You see?
Let me see if I got one sitting here.
Yeah, it's the ones I have are like the big blue ones, the big blue capacitors.
Would something like one of these little guys work, or?
Yeah, they would work just as long as they're a low microfarad.
I have 0.5 microfarad.
Yep. Yeah,
2 of them.
Yep. Hook that up to a full wave bridge, and then hook it up to a small coil that would go on normally it'd be the secondary. So just put it side by side to your transmitting coil. Oh, I meant to ask you too. Have you taken 2 of your Tesla coils, point them at each other on the table, tip them over, point them at each other, start both of them up, take your bulb you got in your hand there and put it in the middle, and the whole light will light up. It's set for in the middle where the 2 Tesla coils are pointing at each other. Like,
Yes, I have done that.
Basically, yours.
I wonder. So you're breaking up there, Mike. Yes, I have put 2 Tesla coils at each other, and yes, they do create a dead zone.
Yeah, it's pretty cool, eh?
Yeah.
And Eric Dollard, he talks about this, and he says he doesn't know where it goes. He doesn't know where that power goes. He thinks it's going into counter space. So basically, it's
being down converted back to the ether.
Well, he's saying it's dimensional. He says it's
or
going
high upper converted, whatever. It's being converted back into the ether.
Either the ether, or he says it's going into counter space or another dimensional. He says,
as I understand it, I thought counter space was the ether.
Well, counter space and the ether, yeah, same thing, but he thinks it's a dimensional thing.
Oh, because it's a higher dimensional like plane of existence or whatever. Or plane. Yeah. I don't know if it's a plane of existence, but it's a higher dimensional plane.
Because if it goes into the ether holds that energy. So technically that light should work. But because they're focused in the middle at each other, it disappears. It's like it cancels itself out. The energy's there, but it disappears. It's not even in the ether anymore. Where is it gone?
You don't have a disturbance anymore. Maybe it, like you said, it cancels each other out and produces nothing.
Well, he says the energy is there because
it is there.
It is there because you got the gas inside the tube, right? Well,
Right.
how's the tube getting separated? The gas goes out
Oh,
throughout the whole thing. It's pressurized.
I guess I would have to see it visually to understand fully. But yeah, I guess. Huh.
So
Well,
he says that's a mystery. And he's a real engineer. Like he's an old school electrical engineer. And he says it's like it's gone into another dimension. He doesn't know where it's gone.
So check this out, guys. Sorry. I'm getting static on the thing, but it's not lighting up. So
It's like the skin effect, right?
yeah, like right here, I'm getting static out of it.
Yeah. I've
and
done
that's
that.
the coil's plugged in.
Yeah, I'm hitting 40 volts on this thing, man, and I don't think I have a high enough frequency on it.
Oh, what's the frequency at?
I have no
Are you
idea. I
getting
don't have it set up.
are you getting little arcs coming off your fingers off those little prongs on the end? Like are you seeing little arcs?
No, I don't think I have it wired right. But I'm getting a little bit of static off of it, which is cool.
Yeah,
I'm
it
gonna
will
have
pick
to-
it up. It's creating the skin effect, I think, on it.
I'm gonna have to redo that in here in a little bit and see what's going on.
What is the skin effect?
The skin effect is it's electrostatic in nature. It's like when you get near a Tesla coil, right? It doesn't penetrate your body, but because it's a high frequency RF, it's touching your skin. So your skin's going to get charged, but it doesn't have enough power to actually penetrate your body.
Penetrate. Oh. Okay, so that makes sense. So it just affects your skin, like you can make your hair stand up and stuff.
Right. It's electrostatic, where if you put your finger in the light socket, you get killed, right? Because it's got the amperage behind it. It's part of the heavy side component, right? Where a lot of electrical engineers today totally don't even look at that effect. Where Tesla understood it, J.J. Thomson understood it, Maxwell, all these guys, even Faraday. Who else am I missing? They all knew it was there, right? But they just denounced it because they felt, oh, it's just static. It's not real power. Well, it's not real power until you convert it. That's like reactive power. Everybody says, oh, reactive power is not real power. But when you dump it into a capacitor, it becomes real power. So reactive power is very easy to convert into real power. And a lot of all our science today, all our electrical engineering, they know the reactive power is there, and they charge more money on a hydro bill for reactive power, especially for like say machine shops and stuff like that require a huge amount of reactive power. They charge more money. Meanwhile, it's not even real power. They say, "Oh, it's not real power." Oh, but we're going to charge you more money for it.
Yeah.
Because they say, "Oh, it's not real power," but actually, you need it in order to run your machinery. Without the reactants in the system, you can't power up, a 480 volt machine that draws 80, 200 amps, whatever. You need that reactive power to accelerate the charge in the system. So they say it's not real, but we're going to charge you more for it anyways.
Yeah. That's crazy.
Yeah.
At least they could be honest and tell you it's real and then charge you for it.
Yeah. But reactive, even Tesla, he talked about reactive power a lot. He says reactive power is almost just as important as the regular power. He says, as long as you convert it over, dump it into a condenser or capacitor. They called it condensers back in those days. And it can be utilized. Same thing with an electric motor, starter motor, stuff like that. What do? They put a capacitor from the positive to negative, because when you hit the motor with current, it creates a huge reactance inside the motor, it creates a surge. Well, instead of capturing that power, they dump it into the capacitor to filter it out.
Hmm.
Right? The reactance is almost like a driving force. It's actually like it simulates like an amperage, a current flow movement. So regular power is not as reactive or responsive as reactive power. But
Gotcha.
if you know how to utilize it, you can actually make the reactant work for you. So basically, that's what I'm getting at.
Don't they dump most of the power into the ground?
Yeah, they ground it out. So they either ground it or they put a filter capacitor between the positive and negative on, say, like a motor. So that's kind of the weird thing how they've kind of dismissed the potential and the way it is. Just ground it out. It's wasted power.
That's just horrible.
So my Renegade device is completely the opposite. I'm embracing the reactants. I want the reactants.
Yeah.
Because when you switch it really fast, guess what happens? The demand from the battery that's running the system goes to zero.
Nice.
That's why my Renegade device can run on dead batteries for months. I had a set of 9-volt batteries. I put 5 or 6 together in series. And the damn thing runs for 6 months. It still runs. So
Nice.
So what's happening, because I'm enhancing and embracing the reactants and also the transducers, enhancing that effect in the coil, when I use the switching method that I do, when it releases a physical release in the switch, all the current that's coming out of that battery goes to zero. So the electron or the ions inside the battery, when they're going from the positive, negative to positive plate, they never actually exit the battery. They stop right where the point where they're just going to leave, and the switch goes off. So it stays in the battery. That would explain why I can run it on dead batteries and keep going.
So it always keeps a charge in there, even though they're dead.
Yeah, because I'm not extracting any potential out of the battery. The only thing I'm extracting from it is the voltage potential, not the current potential.
Nice.
If you only extract the voltage potential, your battery stays charged. It doesn't go dead. And
Because batteries generally work on the current.
That's right. And that's why all batteries die eventually. Where mine, all it wants is that voltage. So I use
Nice.
30, 40 volts, put a few batteries in series, and they could be small, little, tiny 9-volt batteries. So they don't have to be big. And they'll run over 6 months.
Nice.
And then
Did you have to change those out since you built it yet? Or are they still the same one?
No, I'm still using the same batteries. Still the same ones. I haven't changed them. It still goes. And to boot, I'm dumping it in and I'm running, a 4.5 watt light bulb for God knows how long. It defies the logic. If I show this to an electrical engineer and say, oh, by the way, these batteries have been dead for 6 months, but it's still running my motor, and I got enough potential in there to run a 4.5 watt light bulb continuous for 6 months. He's going to go, that's impossible. That cannot happen.
Yeah, that's what they say. That's what Gerald Morin always said. Same thing.
And Gerard Morin said it. He says, as soon as you make that disconnect, the current draw from your power source goes to zero. If you're not drawing any current from your power source doesn't run out. It doesn't get exhausted.
Yeah.
So building you could have the best pulse motor in the world, but if you don't have the proper switching and the reactants happening in that coil to help you, you're already dead in the water. It starts right at the very beginning.
Yeah.
If you know how to switch, prevent that battery from getting drawn of its current, you're at a loss. But if you know how to do it, your battery's going to last for a very long time, and just keep going. So, and the other big mistake people make with pulse motors, they're always running at 12 volts. Don't be a wussy. Go to 40, 50, 60 volts if you want.
Nice.
Don't stay with 12 volts. Don't be a wussy.
Huh.
Go up higher. Don't be afraid to go up to 40 or 50 volts. Like my big Renegade, the big one. Go ahead, sorry.
Yeah, when you're talking pulse motors, you're just talking the ones that you build. We're not talking BLDC you buy off the shelf. We're talking something that you built.
Right. Yeah. And I got all the Renegade devices. I got 460 videos up on my YouTube channel. I got the big Renegade device. I got my small little tester devices, and they basically all work on the same principle. And the big one, that weighs about 100 pounds. I got 4 motorcycle batteries in it. And that thing will run for months and months and months and just pump power out.
Well, let's take a look, Mike. I'm going to pull up your device real quick. Is there a certain one you want me to do? Pull up?
Yeah, pull it up on the...
I love it, Mike. Don't be a wussy.
Hi, Gerald. Glad you made it.
Hey, guys.
Hey, Gerald.
Let's see.
You should see what happened to this.
I'm sorry.
Go ahead.
Go ahead. Sorry.
I was going to say, you should see what happened to this motor. I'll have to show you a small video after.
So
sorry, for context, earlier I said...
There's a big box that's lit up in blue. I don't know if you see it just up there in the top right. Yeah, that's the Renegade, I think, there. Yeah, that's the Renegade device there, the big one.
Let's take a look.
I did that a while ago.
I like that.
Hey everyone,
his
it's
opening
Mike from Fairday Research. It's Saturday night. Hope everybody's enjoying their Easter weekend. Don't forget, if you haven't become a member, bottom right-hand corner. Also, at the end of the video, give me a thumbs up. And also, if you haven't become a Patreon yet, you could do so below. And also have my PayPal donate if you like my experiments and you enjoy what I'm doing and you think I have something that is going to be... to help everybody out and further their experiments in the right direction. You could do so below. So anyways, I've been doing a lot of testing. As you can see now, my generator coils are producing 19 volts. Before, the best I was able to do is 12 volts. Now I got it up to 19. I added a small little capacitor. It's 60 volts at, I believe, 27 microfarad. It's very small, but it was enough to put a buffer on it to get the voltage to go up.
Nice.
So I got this coil, and the coil at the back. Those are my pickup coils. So whatever power that this wheel is generating, now these coils are picking it up. The one at the far back there, that's the drive coil. So I'll let you see the numbers. Now, I've been running this battery down. It started at 50 volts about a week ago, and now I'm at about 48.38 volts. So this battery is slowly wearing down, little by little, but it seems to be holding itself. It seems like it's going down slow, but extremely slow. And I'm still getting a fair amount of RPM out of this. And yeah, so after a while, she starts getting a little bit slow. I think I do have to recondition those batteries again because I've just been doing testing. hasn't been getting the proper charge back to it. But that's what I've been working on here. So as you can see, right now I've got about 19 volts going into, and I've looped it, and it's going back into this charge battery. So it's a matter of how much current I'm generating.
So hold on real quick, Mike.
Yep.
How much more do you have to get out of that, or did you get to loop it to the battery to make it even?
I've looped it. Yes, it does work. But if you get it to the point, if you got your switching correct and your battery doesn't wear out, who cares about the looping anymore? You see what I'm saying?
Yeah.
So because I'm drawing such a tiny amount of current off those batteries, and they're 4 motorcycle batteries. So that whole package together, everything, is about 100 pounds. It's heavy, especially that's a server case. It's all steel, and it's a fairly big unit. And
It's a nice setup.
yeah, it took me a while to design it, but it turned out really, really good. I was really happy with the results. All those coil holders there, that's all 3D printed. I did that on my new printer.
Oh, very nice.
Yeah, I custom designed it in Fusion 360, and I printed all the coil holders. So each one of those coils weighs over a pound each of 24 gauge wire.
That's a lot of wire.
Yeah, that is a lot of wire.
A lot of wire. I bought a spool of 5 pounds, and I used pretty much all of it. So,
wow.
You're in the wire pound club.
Yeah. Well, it's energy to mass. That's what Joseph Newman talks about. And that's another big component of why the reactance does what it does and preserves the battery, because of the size of the coils.
Mm-hmm.
So the wheel itself is 12 inches in diameter. So just to kind of give you an idea how big it is.
Is there a lot of weight to that center, or is it pretty light?
The wheel, I would say weighs about a pound and a half.
Okay, that's not too bad.
Yeah, about a pound and a half, I would say. It's pretty beefy. And I believe it's got 9 magnets on it. Yeah, 9 or 10 magnets around it.
So you showed 19 volts. Did it get up past that? Were you able to push it up in the 20s?
Yeah, you can. I actually got high voltage, a little board. You know, I've had it as high as 250 volts.
Oh, wow.
But a very small current.
Yeah.
But so the idea is to dump that into a very large capacitor bank, and then you can store that and then dump it back into your drive batteries, and just trickle charge the battery as it's running the system. But what's also kind of cool too, because I'm drawing such a little current, if I shut the motor off for a couple hours, the batteries restore themselves. They're lead acid. They have a recharging capability. They re-gauge themselves. I turn the thing back on. The batteries are back up to 50 volts.
Nice.
I'm back to where I started. So
you use so little on your trigger that it really doesn't make a lick of difference when it comes to your batteries. Your recoup is probably more than your trigger cost, actually.
Exactly.
Yeah.
Mm-hmm. Exactly. The battery doesn't even notice a load.
Yeah.
I'm taking so little off it.
I have that same issue.
So, but it's if you get it right at the beginning of your circuit, right from the battery right to that trigger, if you get it to a low current, you're going to win the game.
Yep. Absolutely.
So it starts right at the beginning.
I'm going to have to build one of these after I'm done winding wire and stuff and finishing out my other stuff.
I'm building a new coil. I've been saving up. This is silver wire, and this is 24 karat gold.
Oh, nice. Wow. You got gold, 24 karat gold wire for a coil.
And silver. Yeah.
Wow.
Very
That's
nice.
awesome.
So I'm building something new. You'll see in the very near future.
Nice.
I just wanted to show that.
The evil
Awesome
side.
job. Awesome job, Mike. I'm telling you, you're there, buddy.
Yeah, you just have to learn reactive power, man. It can do wonders for your system.
Yep.
Do wonders. And I think that is one of your best shots of getting over Unity. If you can master the reactants, yeah.
So did you put out a schematic for this device?
Yeah, I do have it on my Patreon. I've done, I think, 2 revisions of it. So anybody who's my Patreon, they can go on and download it and utilize it, use it.
Nice.
I use the automotive car relay. They're like $5 at Canadian Tire. You could probably get it at UAP or Princess Auto or places like that. And that's the switch I use. Those little single throw switches. They're amazing. And
Nice.
I've actually take the armature that opens and closes. I've actually bent it slightly forward, so the throw is shorter now. So as it's going, it could actually trigger faster. That actually helps create the reactants in it.
Nice.
And it's reliable. Like I've run that thing for like hours, hundreds, thousands of hours. You know.
Yeah.
And it just keeps going. I've
Well,
actually, I've
Go
dead
ahead.
shorted the thing probably 20 or 30 times. It keeps going. It's rock solid.
These kind of things you have to run for quite a while to actually see what they do. They don't really reveal their secrets sometimes right away.
Yeah, they're definitely reliable.
Yeah.
That's for sure. The best $5 I ever spent.
Nice. Right on.
Bernie's here too.
What's up,
Good
Bernie?
day. Just
Hey,
popping
Bernie.
in quick before I gotta start another stream over with Certus, but enjoying hearing all your guys' works and updates. Just constantly building. I love it.
Never stops.
Never
The way
stop.
it should be.
Mm-hmm.
Till we're up in the sky and we got platforms that could be put in every city in case of earthquakes, floods, and natural disasters, we ain't stopping. Every city should have a platform that floats. If you know
Until
what
the good work is done. Until the good work is done.
Yep. I wanted to ask you, Mike, you ever use one of these? It's a solid state relay.
Yeah, I've used them. I blow the crap out of them.
Fair enough. That's why I wanted to ask.
No, if you do it with the right one, like if you go to a lower voltage, like I've used ones that are like 20 amp, and I still blow them up. They
Yeah,
just
this
can't.
one's I think 200 amp. 100 amp. This one. Yeah. But yeah, if you're blowing them, man, I don't know. I haven't tried it yet. I just got it. So,
And I think that's where the mechanical switch is better, is because it can handle well, that's the reactants, right?
yeah.
Getting a very sharp spike of reactive power there, that potential that makes havoc on your transistors and MOSFETs and whatever semiconductor you want to use. It just blows the snot out of them.
Yeah, I had to stop using physical relays for that. I was actually using 220 relays out of a furnace for a while.
Yeah.
And you get some interesting effects.
Yeah, but it's kind of interesting too, because like Tesla, he pretty much invented the the spark gap, right?
Yeah.
And I'm really wondering now that he probably used it for a reason. Like if he had something to compare with, say back in those days, they had like say a MOSFET or a transistor, I would almost guarantee you, I would put money on it, he would go back to the spark gap switch.
Yeah, because your transistors, they're great for low voltage systems. But what we're trying to do, I've used every transistor under the sun, including like horizontal deflection transistors, which are 1600 volts and 20 amps. And I blow those all the time. In fact, I just ran out of my last one. So,
but I think the point is, I think that's where the the energy from the vacuum is coming into. That it's the
Spark.
orifice being created, the spark. That's where the excess energy from the environment is coming into the system.
yeah,
I really believe that's the orifice
In
he
the-
creates with the spark gap.
Mhm.
and that's
Didn't
part
Tom
of
Bearden say it's being destroyed too at the same time in most systems?
in most. Yeah, well, they use, like I said, I use the instabilities in my system, but what you're talking about, Ben, it's called an instability, and they ground it out. They do everything they can.
Oh,
to
they
get rid of
ground
it.
it out. That's what
Yeah.
they just
Yeah.
okay, they feed it out of the system like that.
So what I was about to say prior to that was when you're talking about spark,
that or filter.
yeah, cap to ground. You're breaking up a little bit, Mike. But when you were talking about the spark, it's actually part of the theory on the way my coil works, because there's such a very close proximity to both lines of copper interfering with each other constructively. It creates like a low-level plasma you don't see, and that actually gets into the atmosphere and pulls the energy in, as well as, well,
That makes sense.
there's a few effects going on that have to be explained.
But
Is
that aligns with my theories as well.
Yeah, low level. I've gotten
Hey, Gerald, check out
Jeremiah Pop. Oh, nice. Is that your shirt? Made in
Made in
Canada.
Yeah, made in
We
Canada.
need
Way to
more
go.
of that. Mike is
That's
fully
just go
made
to
in Canada.
Giant Tiger.
My son gave me this one.
Yeah,
It's like the Star
Nice,
Wars
huh?
thing. It's a lie, but he gave me this.
you
shirt.
see,
No, I'm kidding. Go ahead.
Hey,
you
if
see-
he believes it,
you
that's
see my
all that matters.
you see, I had my I had my 50-year-old shirt on there last week. Remember?
Old
50-year-old
ball.
balls.
That was a good one. Where's our old ball shirts? Come on, man. Right? Nathan's probably going, you're too far. You're going.
Yeah, I'll have to
Sorry.
get my white pen. Going too far.
Yeah. I'm almost.
We're all good, and then we all got to have an old ball shirt. I need to get one for me.
I definitely need one.
Change the channel name to Old Man Balls.
lagged.
But then the subscribers will get
There you go.
Old
Yeah.
Man Build Balls. There we go.
Oh,
Hey, he'd be a
man.
millionaire if he could do that. What do you mean? There's a lot of guys out there that need some balls. You know what I'm saying?
Oh, man.
Sorry, I'll
Hey,
stop.
the field will give you balls, right? That'll be the slogan.
Hey, but you could go you could go this way too. You could say, yeah, but men are like fine wine; we get better with age.
It's true. Some do. Some just go sour and salty.
And wrinkly like grapes, right?
There you
That's
go.
true.
Yeah. I know a few raisins myself.
Oh, man. They all start out that way. They always end up that way.
Yeah.
Yeah, you got the lines going there.
They just get affected by gravity. That's it.
That's it. See, I wonder if that would be affected if and when we do find how to negate gravity. I wonder if it will affect aging in some way. Right?
That's what you're worried about with gravity?
I was just
Well, you know what?
Where your
here's the
balls are
thing.
hanging?
Well, here's
I
the
wouldn't
thing,
mind a
right?
little Benjamin
You're up
Button.
in the atmosphere, you're chilling out, you're living your life maybe 2 years, and you come down, you ground out, and all of a sudden you're a little more grayer than you expected. You know what I'm saying? Gotta think
Yeah,
about
right.
this.
Like that
And you're
was
kind of
a real
hanging a little bit
concern.
lower than usual.
Really need that ball shirt then, right?
You wanted to go the opposite way, right? Like
Oh, my.
that's kind of concerning, though.
Yeah, you gotta think about all these things. I
All
mean,
of
I'm
a
not
sudden-
saying that's the case, but it's an interesting thought.
Not a question I thought I'd ever ask an astronaut, but now I might.
Yeah.
Yeah,
Yeah.
Well, exactly. Spots
Gotta
like
ask
Mount
them how they're
Howard.
hanging now just to find out.
Might be an odd question to ask right off the hop, though, right? Might want to get to know them a little. Just saying.
Oh,
See, we
man.
might be all crazy, but in the end, we still like to joke around too sometimes, right?
Absolutely. Oh,
Not
man.
medical advice, but laughter supposedly the best medicine. I don't
Yep,
know.
it is. It's all in the head.
That's what they say.
It's all in your head.
Oh,
I
Hey,
laugh all
sometimes
the
you need a
time.
good laugh.
I laugh all the time. I wake up in the morning, I look in the mirror, fuck, I can't help but laugh.
You know what I don't get though? There's some people with those
So-
personality types. They just don't laugh at all, and I can't relate to that. I've never been in this.
You know what the thing is? You got to be able to laugh at yourself. You can laugh at yourself. You can laugh at anyone, right?
Mhm.
right.
But if you're just
Exactly.
laughing at other people, you're kind of that gets vicious.
That's true. That's true. There's a distinction there, and I think that's important to make, Gerald. Thank you for that.
Yeah, I laugh at myself all the time.
Self-degrading humor is my specialty.
Well, you know,
Within reason.
one piece of advice, like when you're working on a project for a very long time, it's okay to drop it for a week or two. I find it's actually good because like I was working strong on the Renegade for well over 2 years, like strong, like nonstop. I had to take a break from it because you get to that point where you feel like you're hitting a bit of a rut. You know, your creative juices, you know, kind of go a little bit.
Yeah, it's equivalent to writer's block, really. Innovator's
Right,
block.
yeah, it's same thing.
Yeah.
And you know, you just have to walk away from it for a little while and then jump back into it again. You'd be surprised the ideas will start to come back and and better ones.
I think it has something to do with stimulating your brain with outside, environments. Something
you got
unrelated to what you're doing. You're
I
so
think-
focused in that state. You need to stimulate your brain with more.
right.
Yeah,
So
I break twice.
like in the summertime, I like to go camping. Right, that's one of my loves. Love to go camping.
Oh yeah,
I like to get out in nature. So when I get back, my mind is refreshed. Being out in the country, there's hardly any RF around. Very little, and I feel different. In in cottage
Resets
country,
your
right?
energy, your consciousness,
Yeah,
everything.
nature can have give you a profound spiritual experience, and help you with your emotional distress, all sorts of things.
Just the air alone.
And like you said, sometimes you have to take a break, right? Like I took 2 breaks. The first one was 2 years, didn't do much. The second time I took a year break, but I was volunteering at a kids camp and being, doing activities and stuff there, right? And it takes your mindset away from what you're doing so that you can actually clear your head and your juices start flowing, and then you're right back at it up.
So new ideas will pop up.
Right. Because if your mind's scattered and all over, how are you going to be able to focus on what you need to come up with next?
Sometimes
sorry guys, I will be listening, but I got to take off and join another panel here. But if you're still going a little bit, I will rejoin.
Shout out to
great work.
Right on, Crypto. Thank you.
Thanks, Bernie.
Thanks.
Later, Bernie.
Take care. Yeah, so I'm really big on life balance. So work hard at your projects, no doubt. Work hard at it, but don't be afraid to take a break. A couple of weeks here and there. Like me, I like to do it during the summer because I like to get out into nature, and it really helps. It really, really helps.
Guys like us, or people like us, get really obsessed with what we're working on sometimes. So it's very good advice.
Just a little.
Just a little.
Yeah, I've done 18 hours of solid experiments.
With everything, right?
Yeah, and I've got.
And you're just like, what? Just one more, and then all of a sudden it's like 5 o'clock in the morning. You didn't get any sleep. You got.
That's
Well, no,
why there's a recliner behind me so that I can go and sit down in it and relax
you
and
go.
watch some TV so
Yeah.
that nobody bugs me in between projects.
Absolutely. My
That's a good
computer
idea.
monitor is my TV, so I'm already set up. I just hit a switch,
Mhm.
kick back, and I'm done with everything for a while. That's how you should do it, right?
Yeah.
I'm not used to seeing you, Gerald, with a camera.
Right?
Because for the longest time he only did it with a mic, right?
Yeah.
Yeah, he
I
was
like that.
That's how we-
Mysterious.
mysterious. It was very mysterious.
Then we
Yeah,
always saw
he's
the
like-
lion's head.
Everybody's
Yeah,
like,
like
who's
the-
that crazy Gerald guy? Well, there I am.
It's the Wizard of Oz. The Wizard of Oz.
The guy behind the
Behind.
curtain. Right?
Yeah.
You just wait. I got some stuff coming up that may make you think I'm the Wizard of Oz, but I'm very far from it. And I'll teach everybody my tricks.
Hey,
So
Hey, if you
yeah.
start making your neighbors like plates and chairs flipping over, then I know you've done it.
Are you kidding? The neighborhood I'm in, I'll be lucky if my neighbors even have chairs and plates.
I could just see him like trying to levitate something on his desk, and then like it cuts to like his neighbor, and he's like, "Dang it, nothing's happening." His neighbor's got stuff flying around, and it cuts back to him. He's like, "Why isn't anything happening?"
It's funny, I can't do certain experiments in the house because at certain frequencies, my cats on the third floor, all their hair starts to rise and stand up. Nothing's going on down here. But on the third floor, cats look like they're in a freaking vacuum cleaner and they're freaking out, right? So, yeah, there's certain experiments I can't do in my house.
Oh, man.
Yeah, this stuff's awesome. This tech is awesome. It's just it's a little bit, you got to know what you're doing. You don't want to be just playing around.
Yeah, I think.
Hey, do you need to fluff your kitty?
You know,
Gerald's house.
Yeah.
You're breaking up, Mike. Go ahead.
It seems like all the stuff. It seems like the stuff that you guys have been working on for so long really tie into heavy side in a big way.
Yeah,
The
heavy side. You could say
potential.
heavy side. Thomas Bearden, Tesla, Bedini. They're all mixed in.
I'm
Right?
not familiar with
Yeah.
heavy side.
Yeah, Oliver heavy side.
Yeah, he was the guy that kind of made a universe in a jar. Wow.
The
A
Star
universe.
Wars?
Universe inside of a 1,000-watt glass bulb.
Light bulb.
My
Yeah.
understanding.
Yeah.
He was
And
a
Eric
heavy.
Baller did the same.
Yeah. It had to do with television. He was
Oh no, you're
correct me
talking
if I'm
about
wrong, but I believe he had something to do with creating the tube television, or he had something to do with that. I could be wrong.
Hmm.
Yeah. But yeah, he was.
the guy, I'm trying to remember the name of the guy that invented Farnsworth, Taylor Farnsworth. He
Yes.
kind of revolutionized the TV tube, but before that, Eric Dollard actually knew his son, Taylor Farnsworth II, and he showed him some vacuum tubes that were just like they were wild. They were
I
like
remember that.
2 cathodes, 1 anode, 2 cathodes, and the whole object of what he was trying to do was create a star in the middle of the jar and suspend itself. That's what they were trying to recreate.
But wasn't that based on
Started jar.
Steinmetz's work?
No, that was based on heavy side. That was based on
Heavy
heavy
side.
side's work.
Heavy side, sorry.
Yeah.
I did get that.
So Farnsworth, ultimately created the TV, and he got screwed over. That's a long story all on its own. But he was working on these cathode ray tubes that were, for the day, they were very exotic. They were like nothing anybody's ever seen. And he showed Eric Dollard these tubes, and he goes, "Can you, tell me what happened to these tubes?" He was looking at them, and they had burn spots and a whole bunch of stuff. And he goes, he says to Farnsworth, he goes, "What happened to these tubes? Did these have a runaway?" And Farnsworth, he was at that point in his life, he was pretty messed up. He was kind of drugged and drunk all the time. And he's like, ugh, like he got mad because he figured it out what was going on. He goes, what was he doing with these ray tubes? And he found out, he told him the whole story and says, yeah, they were trying to create a star or an orb of energy in the middle of the tube.
Yep.
That so when he figured it out, he talked to the wife of Farnsworth. He got pretty close with the family, and that's when they start to open up. And he had access to all of Farnsworth's notebooks, lab notes, everything he had access to.
Nice.
And that's when he came up. That's when he invented the cosmic induction generator, basically recreating what Farnsworth did.
Yeah.
So, and he did that in San Francisco.
I got as many of his videos as he produced about the cosmic induction generator. Took them all off the internet the minute he put them up. Then they all got taken down, and then yeah. They're here.
I've seen it. You know, they're creating a galaxy inside the bottle, and the problem is it's heating up. They were using these old sodium bulbs that they used to use to light up the streetlights in San Francisco, and they switched them all. So they put them all in the dumpster, and Dollard and his buddy there, they managed to get quite a few of these tubes, and they started doing that experiment. So they said the one time he says he had galaxies and comets going in there. The whole universe was basically in this jar, and it was getting hotter and hotter and hotter. And he said when it exploded, just for about a split second, maybe a second, that whole energy ball stayed there in mid-space. It didn't go away.
Yeah,
so,
sounds about right.
Yeah,
couldn't contain the energy of the universe, right?
It just eventually dissipated within a second. So after it blew up, for that split second, it stayed there. It was self-contained.
That'd be amazing to see, eh?
I
have the bulbs, but I can't do that experiment.
Yeah, you need very extreme high voltages with that.
Yeah.
60,000. I think he said 60,000 volts or something he started at. Yeah.
I got access to 200,000 volt power supplies, but I haven't played with them yet. So I'm kind of leaving those for last.
Unless you know what you're really doing with that stuff.
Well, what you really want to do, right?
Everybody out there, do not play with these potentials. These are deadly potentials, please.
Absolutely.
Like even I got a limit, and if you got 60,000 volts at 1 amp, you're vaporized. You're toast.
Yeah.
And at the blink of an eye, not even a second, you're done.
I've seen videos of people literally exploding.
Wouldn't surprise me. It's a lot of power.
It's not pretty.
Yeah, it's a lot of power. That's why I got gold. There's something I'll be doing with it, I'll show. Don't worry. Don't try this at home, folks. I'm telling you.
Silver is good too.
If you don't know the one hand rule,
try silver too.
With high voltage. Okay, go ahead.
I learned that the hard way.
So did I.
I did shoot myself on I think it was.
Keep your hand in your pocket. Because if you're not watching what you're doing.
Ceramic capacitor.
Yep. We'll play the pocket pull rule and you'll be okay.
Yeah. Yeah, we could.
Be alive the next day, that's for sure.
Yeah, exactly.
It hit me like things that they use to revive you.
You're talking about the part machine? You're breaking up a lot, Mike.
Yeah, you broke up a lot.
Yeah.
Yeah, we'll have to wait and see when he comes back.
So I was messing
Yeah.
around with the
Yeah.
Peace Corps earlier.
You know, I disappeared there. I'm just going to scoop. I
Broke
think I'm
up again.
being blocked.
Ooh, that sucks.
Yeah, something weird's going with my internet too. Like it's working, but certain pages aren't loading for me.
Oh,
It's
man.
really I haven't experienced anything like it since I've had this
See,
new internet
when you
service.
get over the target, you start messing with you.
Hey,
I
you
thought
guys
this
leave
stuff
my
only
internet
happened.
alone.
I thought this stuff only happened when Gerald and I talk in private.
I got soap operas to watch, guys. Come on, stop screwing with me now.
I got a video of this new configuration on the Peace Corps transformer. I actually don't use one coil, I use two. And I'm pulsing the primary on the first coil and the secondary on the second coil. But if you don't pulse it in the right direction, nothing happens. So it literally shows the effects where there's a vortex up top and a vortex down below, and it slams into each other, and then all the meters' power goes up.
That's
If
cool.
you hold on, if you put the thing in backwards, they cancel each other out and you get nothing.
Yeah. Yeah.
All right. I'm gonna have to rewire this.
Do you want to see the video?
Yeah, let's do it.
Yeah, let's
Wait,
check it
give me a
out.
sec here.
Yeah, Sean was begging for a demo earlier.
Oh, I got the video queued up for the car. Just show the motor. Hang on.
Mm.
That's what you're messing with today.
Yeah, here I'll just show it really quick. Oh, wait, what's this one? Oh yeah, here's the demo. I'll show the car after. So let's see if I can get this presentation thing going like I did before. Let's see, present, share screen. Here, I'm getting good at this.
Right
You
on.
can see it? Yeah? All right. So I'll hit play. The audio sucks. So what you're seeing, hang on. I'm trying to get it at a good spot where you see the transformer.
We're gonna have to get you a tripod to sit this thing on.
Right? It's going to show the neon blinking, but it doesn't show the meters in the background very well. I don't know if you can see that. Okay, so that's the first meter, the second meter, and the third meter.
Got it.
And then when I hit the button, see, I'm moving it way too much. I apologize. I was basically just trying to show that I'm pulsing the neon into the battery.
Okay.
I think I have the wrong video to show you here. That would figure. Yeah, give me a sec. Sorry, guys. It's been a long day for me.
Sounds like it.
Yeah. Yeah.
Yeah, everybody was looking forward to your presentation on your circuits there, Gerald.
That's my bad. Okay, so what am I showing here? All right, now I'll try this again. I'm not sure if this is the right video. I think it is. Of course, it's not showing it. I'm not as good at this as I thought, darn it.
Oh, man. Well, you get it. It'll be on there in a minute.
All right, so maybe I got it this time. There we are.
All right, this is the
Great.
one.
So, yeah, so as you can see, can you see my mouse?
I can see your two small coils in there, and I can see all the ferrite cores with the coils.
Yeah, so there's 3 legs of ferrite cores, and then there's 2 vortex coils, and the pulsing is inverted. So like I said before, I'm pulsing the primary of the top one and the secondary of the bottom one. But if I switch the pulse rate in either coil in either way, they cancel each other out. You could see on the meter right now 86 volts, 36 volts, and the other one reads 12.10. So that's just the first signal being pulsed. The second signal will show up as soon as I hit the button, I hope. Okay, so what you saw was the neon flash. The meter over in the left-hand corner is at 124 volts. The middle one's at 48 volts. And the one where the battery is at 12.10.
Huh.
So, let's see. Hit it again. Well, the kittens are awake. So as you saw there, the battery went up slightly. It takes quite a bit to raise the battery when you're just using straight voltage and you only seen 3 pulses. But basically what you were seeing is your signal firing one way and then your signal firing the other way.
Gotcha.
And then when they meet, I'm getting an exponential amplification of voltage. Right? And I can do that with one coil, but I wanted to test to see if they were going to interact that way. And they absolutely do. If I create spin, say to the left on the top coil, and then I create spin to the left on the bottom coil, they cancel each other out. I get nothing. But if I create left-hand spin on the top and then a right-hand spin on the bottom, it doubles my voltage.
I'm going to have to remember that.
That goes to part of the... Sorry, go ahead.
I was wiring my Tesla coil.
I seen that.
So I think I just wound it wrong. And it's probably going in and out the wrong way.
Yeah.
Something I'll have to learn. I'm new to this, so I gotta start somewhere.
Okay, so I'll tell you what. I'll give you a bit of do I have one here? I'm looking for one of my boards. I don't think I have one handy. I'll give you a nugget on Friday. I'll show you my template and I'll explain how I wind it or how I wrap it so that when you see it, you go, okay. Because then that's the next step closer to what I'm doing. There's still 2 more tricks you'll need to learn after that. But I'll teach you that nugget on Friday. Because then I'll have my template out and you'll see the numbers, you'll see the colors, and then I can show and demonstrate how it's wound. Because it's significantly different than yours that you tried, than Jeremiah's, than Charlie C's. Everybody who's winding these coils, I've done something different than people are seeing. And because of that, I think that's why it works better than others. Doesn't mean that yours isn't going to work, because you kind of have the right principle, but it's the way that you're winding it. And you're only coming out with a 1 wire in, 1 wire out. Remember, it's bifilar. You have to have 2 wires in, 2 wires out when you're done.
So, well, that's part of what, you don't always get to see. I just see this coil that's sitting there in, resin. I don't see the windings going in each level. Right. So I can see how many levels it's got, and I can predict how the winding might go based on that level and the size, but I have no idea which way it goes.
The reason why I put this in resin is because I wasn't getting breakout. I was literally getting EVOs form in geometrical patterns underneath the coil. Wasn't burning through the insulation. There's no burns on the insulation at all. Tested the same coil the following day, less voltage. Didn't get them out. But I wanted to have it in resin so that didn't happen again. Jeremiah Pop did a video a couple years ago, and we were discussing the experiment. He did an experiment, and he even proved that the EVOs in Myke Power's coil was coming out and breaking out between the wire. And we thought, okay, it's breakout, the coil's messed up. But it wasn't. It was actually EVOs forming between the two cross sections of wire. Because when you push it, it doesn't like being pushed. If you give it that subtle sort of pulse, you give it the ability to build the bubble and build your excess energy like a slow amplification. But once it gets to that amplification, you can keep it there all day, all month, whatever, right? So you've got the right idea, man. Twice, both coils, perfect. Just slightly different than what I'm doing it. And I did the exact same thing you were doing. You've seen it in some of my coils. They're very basic, some of them. Some of them, not so basic. They're a little difficult. Wait till you see the next one that comes out. This one's next.
We got to catch up with the first one now.
This
now
next
go on to the next one.
So difficult. It's even running me for a loop. So, but
now, hold on. I did my winding and I showed it earlier. Okay.
Yeah.
And I just about done it from memory. Okay.
Yeah.
So I can wind whatever you got. It's not done the right way and it's bothering me because it's like like you said, the idea is right. The execution is horrible.
Okay.
It's not coming out right.
When you made your form, you had it 3D printed. And that's an awesome idea, but you have no number sequencing beside it. And that's the thing that I think you're missing that's getting you messed up. I seen you wind it, and you winded your triangle. You went and you did your loop, and then you offset it one, you wind another triangle, right? Well, it ended up being a hexagon, right? Because that's what it was. But I noticed once you got to your third offset, you were kind of getting mixed up. So you have to have the numbers in there when you're winding this because you get so far into it, your brain mixes up sequences and you'll mess the whole winding up. I've done it. I've done it so many times.
Sometimes you just have to play around with it and do it a couple of times to find your rhythm. You know, like I said, like you got to find your method and it takes a little trial and error, but you'll get it. You're doing good. It took me like 3 times winding the rodent coil before I actually had something usable. Like I screwed up the wind a couple of times. The twisting, the multi-filer or whatever.
So hold on. What was it? A 6-sided star that you were creating?
Me?
Yeah, on the bottom layer?
No, but it ends up looking like a 6-pointed star once the sequence is complete. But that's not what I'm creating. There's a dodecahedron in this.
Really?
Yeah, there's more in here than you could. It goes back to. I don't want to give it out because it goes to part of the theory. But I've been studying stuff like the flower of life, Mandalas from India. I was reading the Vedic texts for like 3 years. I got heavy into the old ancient religions and philosophies, and they all are interlinked. Now, mind you, that was all after I got inspired by the dream, but still, it's all interconnected.
With how much you know and your body of knowledge. That all makes sense. You studied the Sanskrit. That's something that I haven't even delved into yet.
I did this wrong, but I did it right. Yeah, I even studied the Kama Sutra. Okay, so I kind of compressed the numbers a little bit, but I'm going to try and give you the gist.
Hey, you want to turn that board a little bit so we can see it a little better?
I will, but I got to draw them out first. Okay.
It's got a double numbering system.
Yeah, you see it, right?
Yeah.
Okay. I can't draw the double number because I don't have room and I messed up the circle.
Charlie Brown.
It's a big golden nugget, people. Pay attention.
Hold on. Let me put this on.
So there's a sequence. Of course, I draw really crappy. I should probably draw it properly for you guys, but I'm in a hurry, so I apologize. What we have here is a 24-hour clock. 1, 2, 3, 4, 5, 6, right? So you have 6, 12, 18, 24. And you go 1 to 24 all the way around. But then, like Nathan had said, there's a double number sequence. And you go the opposite direction, like this. 1 becomes 24, 2 becomes 23, 22, 21, 20, and so on and so forth. Actually, I messed that up. Because this has to be 18. I'm messing up my own number sequence. Apologize.
Oh, man.
As me dear departed father used to say, you got to do it right, or don't do it at all.
Oh.
All right. So because I messed up the numbers, it's not looking right. But this is supposed to be an 18. This is supposed to be a 12, of course. This is a 6. There's a 24 up top. So reverse all the numbers in the number sequence between 1 and 24, right? And then that 24 becomes a 1. You go back the other way.
Well, it would help if you wrote 24 up on the top.
I know, but now I gotta draw the whole thing again because of the writing I messed up here.
Well, yeah, that's why you can't go backwards with it, because you forgot a number.
All right, you guys carry on amongst yourselves, and I'll draw it properly.
I'm gonna have to watch this again and again to figure this out. It's driving me nuts.
This is a golden nugget. This is something that I didn't tell anyone. Jeremiah, Michael Perrone, Tim Ventura, nobody. This is a nugget I'm giving out today that has never been seen. This is something that it's kind of a secret I've been holding. Why? Because I wanted to be the one to demonstrate it so that everybody can see it. Hopefully I could demonstrate it correctly. Oh, I know I messed up the numbers. Right. So Michael Perrone had said earlier, be careful because when you're keeping things to yourself, that's how you could get disappeared, so to speak, and your stuff gets disappeared. Well, I have 3 dead man switches, 1 physical, 1 digital, and 1 in another form. So something happens to me, it's getting out to the public no matter what. And I've said it multiple times, I would never commit suicide. It's not my belief system. So if someone's coming to get my info, they actually have to get into my house. Good luck with that.
There you go.
So that makes this
23.
Yeah, that would make that 23 because the 24 is still going to be there. This is going to be 18. 12 stays the same. This is 6. And you follow this sequence, right?
So hold on. So is the first wrapping all one way and then reversed?
That's something I'm going to let you figure out till Friday.
Oh, come on now.
Sorry, just kidding. I had to do that. No, it isn't like that. it's like this, okay? Golden nugget, everybody. So you would wind, let's say, we'll say 1 to the 3 to the 5 to the 7 to the 9, 11, 13, 15, 17, 19.
Braiding.
Okay. Wait. Because I did the sequence like that, I now have to go to the 1, to the 3, to the 5, 17, 15, 13. You got it?
I got it.
These are 2 different wires. Okay? They're not just one wire. Do you understand what I mean by that?
So if I did it in red and green, we're good. Just like you did there. We're on 2 different windings. Is that what you're saying to me?
Yes. Let me show you how I start this off so you can kind of you got the number sequence, right?
Yeah.
So to speak. But what I'll do
So for every time I've ever seen the double star, they had the braiding on the outside.
I know.
I just saw you put the braiding in on one side. Does it loop to the other side though? So to make the braid, one goes around the right side, one goes around the left side. Does yours do that, or does it stay all on the right side or on the inside? Because you showed the loops going on the inside.
Goes on the inside.
Okay.
Okay.
So I had that part right. All right.
So let's say your numbers are here. Okay, so when you come in and you start your number sequence, let's say this is your copper, okay? Your red's your copper. This will be the line that your copper's wrapped around, sort of tied to. Same thing with this. So here's your primary. You come around, we'll say for the example, these are nails, okay? Or screws or posts, whatever. For the example, they're nails. So your copper line would come around the nail to where your 24 point is, and then you would start your winding. So then let's say you go like this, okay? You come back. When you come back to that square, you go back around and you just loop it there and leave it there. Now you got a spool of wire here, right? But you're just looping this wire to hold it. Then you're taking this one, coming around. You're going the opposite direction. And then you bring it back around the nail and you just loop it there. Then when you do you come back to this side, that's when you bring it from this hook and you go back around again. That's what I mean by bifilar. That's how it's woven. You understand what I'm saying?
I get it.
That is a very significant key difference between the way I wind coils and the way anybody else has ever wound geometrical coils. Now, there's 2 more tricks in there. Wind it the way I've showed you because you need to learn. And if you do it perfectly without me teaching you these tricks, it'll work great. If you do it and it doesn't work, it has to do with these 2 tricks.
Okay.
Okay. So again, like you said, you wanted to learn how to do this. Well, the only way to learn, cut your teeth. is actually to get her done. If I teach you every little bit and piece, you're going to be like, well, that doesn't make sense. If you do it like, how do you get that? So you have to wind it to get to that point where you get stuck. And then I can teach you that trick and it'll sink in your head. You'll never forget it. Otherwise, you have a hard time with it.
There's a causational relationship every time you wind a wire around a post. And how you pass that next hurdle is what you're talking about, right?
Yes. And when you had discussed about making your 3D form and you had your post come up and you have your plate come over top. Now, when you wind your wires around, let's say your nails or your posts, the reason why I use a circular, a screw, a nail, a post, whatever, is so that I can slip a zip tie in there and tie it so that they compress flat. There's a purpose for that. That's why you see my coils. Sorry, taboo to go off camera. I do all the taboos. That's why you see my coils. They have the zip ties around, but they're pulled and compressed. Okay? And that forms part of the field. It actually allows the field to show anomalies. Okay? Does that make sense? Okay, so
you said imagine the flow, and now you're pinching the corners, so you're getting a flow.
Yes, and I'm using the pinch in the flow for magnification purposes. That's how I get dichotron instability. That's how the skin effect comes into play. There's a bunch of different things that happen because you wind it like this, and they wouldn't happen otherwise. And it's wound 180 degrees out of phase, bringing in that resonance the second you hammer it. Why? Because it's 180 degrees out of phase just by the very design that it is. So there you go, guys.
You're not going a different direction. You're just going two different wires. Is that what I saw earlier?
Yes, but they interweave upon every different number sequence, locking themselves in and forming the compressed field. Remember, energy doesn't flow in the wire. When you're using this stuff, it flows around the wire. Right?
All right.
So because of that, you're able to compress that plasma within those fields.
Nice. Okay. Now,
so big nugget. There you go. Now everybody can build them. You don't need me anymore. I'm just kidding.
That's not true.
Yeah,
we're all gonna get
overlapping of fields.
I'll teach a class on this. That's why I built so many. I'm at 178 now, and when this is done, I'm going to be at 179. I'm shooting for 300. We'll see.
Anyways, guys, I gotta head out for the night.
Myke, thank you for stopping by. I really appreciate it.
Yeah, thank you.
Yeah, thanks. Yeah, thanks.
Awesome work as usual, Myke. Awesome.
Are you on this Friday?
Yeah, we're doing Friday night as usual, 9 o'clock Eastern, right at Faraday Research, and I'll send my invites out before the show, and hope you guys can jump on.
I should have my new stereo amp by then, so hopefully I'll be up and running the demo.
Very good.
That sounded fun your first, Ben, the way you said it. I'm sorry.
Yeah, we'll be there, Myke. And
later, Myke.
Myke.
There's a catch my throat.
Friday on some tree power to share, but we'll talk Friday.
Okay, sounds good. See you.
Much love.
See you later, Myke. I was supposed to show off that experiment between the barn and the tree, right?
Yeah.
Couldn't get out there because I got a call. I was halfway on my way out there when I got a call for the car and the breaking down. Let me show you the motor. You got to see this. Is that okay?
Let's take a look.
This is funny. She apparently was at a red light and all she heard was bang. And then everything stopped. And she couldn't move and she didn't know what was going on.
Oh, did you throw the rod?
No, actually, she broke a motor mount.
Really?
Just one of those weird kind of off the wall things that happen.
And it stopped the motor?
Not the motor, but the whole motor shifted because of it.
Right. But did it? You said everything died, so did it stop the motor at
Well,
all?
you know what happened is when the motor shifted, the air filter system came off, and the whole motor moved, so it just shut the motor down. The wild part is nothing broke, not even the fan shroud, nothing. It's all perfect.
Wow.
It just shifted and shut off. But look at the shift, though. I don't know if you can see it. The whole
That's
motor's
crazy
to the
lucky.
left and forward.
Wow.
We pulled out the battery box to see if we can get in there, but as you can see, it's like we're gonna have to use a come along or
picker?
to get it done.
Yeah.
So let me tell you, Gerald, I had an old Chevy, okay? And we basically took baling wire and reattached a motor mount on one side of it because it would literally, as you hit the gas, go like this.
Yeah.
This is back in the day when you had no money and you first started out. So I took a 350 Chevrolet and I took some baling wire and I rehooked a motor mount in there to get home.
Nice. You do what you gotta do, right?
That's right.
Yeah. My dad had an old police interceptor that he managed to buy at an auction, and it had a 454 under the hood with a 4-barrel carb.
Nice.
And there was a motor mount that was ready to go, but it didn't go. And when he would step on this thing, the tires would light up and the whole thing would go, and you could feel the car turn.
Yeah.
One day he thought he was really good, and he hammered it in the back alley. All you hear is, and then it was done. And what happened is the motor was so strong it twisted the frame, and it blew the drive shaft right out. It just hit the ground and skidded off into the fence. And
Nice.
it happens when you got that much power, right? That's one of the biggest motors out there. So interesting stuff.
I've dropped more than one drive shaft in a car. So
Yeah.
Tell you what, before I was 21 years old, I've had 18 classic cars. They weren't necessarily classic back then, but we're talking 71 Camaro, 72, 73. You know what I mean?
Yeah.
Any kind of Nova. I've had 6 Novas so far, all in the 1969 to 72. Okay. El Caminos, old Chevy trucks, everything. I used to take them in a 2,500 square foot building we had in the backyard, and it was a big metal building. And I used to rebuild them, take them apart, put them together, take everything completely apart from this whole thing, clean it, put it back together. I never wrote down anything, never marked anything, just did it. I was able to memorize it and put it back. And man, there's some beautiful cars in there, man. I ripped up and down the streets and every single thing I could find.
Yep. I love old cars. There's
Young man builds.
Yeah, there you go.
That's right.
Wheels the tires.
Hey,
The prequel.
once I figure it out, it's game over. I figured it out forever.
That's it.
You want to hear more about those stories of his young man build days? Hit that subscribe button.
Yeah.
And don't forget to like. I'm just kidding.
Oh yeah.
There's I can't remember his YouTube name, but I love the way he says it. You gotta smash that like button, smash it hard. It's hilarious the way he does it. I don't do it right. I don't give it justice.
It's
Gerald?
okay. You could do it in your irate Irishman voice.
Your drawings, I swear, man. Every time.
Oh, you would howl. I had a circuit up here earlier. Yeah, you know what? I should probably wipe this out. It kind of looks like a cervix. I shouldn't say that, but sorry. I had a drawing up here earlier, a schematic. Man, I drew it. It was like the perfect circuit. I'm testing it right now, and I come back in the room after testing it. I looked and I went, "Oh man, I should take a picture of that. Nathan's gonna howl." Again, it was the same thing, man. I don't know why. Maybe it's just something on my mind.
You can't,
like
you
being-
can't draw a circuit without having to do with some kind of a body part. Every
Well,
circuit he draws.
You know what I
It's
had?
like-
I had 2 coils, right? And then I had the circuits go, and you know what I'm saying? And it was just bad. It was bad. Oh,
It's like being in the conference room when Jeff Bezos was pitching the rocket.
I should not be a drawer. That's just the way it is. Sorry, guys. I'm not, I'm of no illusion.
Oh my, that's so funny. Dude, he's so proud of it too. It was so funny.
Oh, yeah.
There comes this little notebook and he's showing you this drawing, right? Look at this. It was so cool. I did this. And then you're like, well, Gerald, that's a pair of, I go, what'd you draw in the middle there? And then it was like, it's just a circuit, Nathan. It's just a circuit.
Yeah. Well, it didn't look like one, I'll tell you.
Maybe that's why your circuits work so well. They're all producing
There you go.
something.
Yeah, they're based on something, all right.
Oh my man. Only this group. I tell you that right now.
Gotta have fun with life, man. It's too short.
Oh.
Yeah.
So Gerald, now I'm gonna have to learn your circuits because once I get these things wound right, then they'll flow right. So I'm gonna have to learn which ones you're doing. So I'm gonna have to go back to last week and kind of look at what you were putting up.
Well, the book that I'm writing has I don't have all of them in it. I think I have something like 60 different number configurations for the coils that I've made.
Okay.
But in my binders, I have all the rest. So once I get the book finished, they should all be in there. And if not, maybe I'll put out a second book later on. But you'll be able to build everything I've built. I'm not holding anything back. You know what I mean? What's the point?
Yeah.
I could be dead tomorrow. I could be dead in 20 years. Who knows? Let's not take the risk.
I think I got to start at
No,
square
yeah.
one. I got to get frequency in there and then pull a load on the other side. And
I'm at the point now where I can start it with a frequency and shut the function generator off.
You don't even need it. Yeah.
Yeah.
It just keeps on resonating with itself. Yeah. That's cool.
Crazy stuff going on, man.
master of his craft right there. That's for sure.
The Lord of the Rings himself.
I never considered myself an expert, and Ian was the one that brought up the or was it Sean? I think it was Sean that brought up the explanation of an expert, saying that you need 10,000 hours.
Mhm.
I'm way over 10,000 hours in working with these coils. Way over. 2007 was the first
He's
one.
in legendary class, ladies
Yeah.
and
Well, I don't know about
gentlemen.
that. Till they're flying. If I can make them fly, it'd be legendary, right?
I want his loot crate.
We're not there yet. So, but one day, very soon, right, Nathan?
That's right.
Very soon. We're both
Right.
going to do it on the same day.
I think we're I think we're about one more avenue short of where we need to be. And I have a person who's really good at it. And it's about taking your fields and getting the opposite reaction out of it when it comes to something that turns out to be high voltage. And it's all about changing the charge aspect of it. And he's really good at it. So he builds lifters that carry weight, and he understands that, you know what I mean, how to do it without ion wind. And that's amazing.
Yeah, that's what we want.
Yeah. So we have Ben's guys coming on next week. And then after that, I think we're going to have my guy come on. And they call him the Black Tony Stark. So
Nice.
he's awesome, man. He's one of us, trust me. But I think it's going to help out our cause a lot to figure out a little bit more of where we need to go.
Yeah,
'Cause we
everybody
have
has a
all the
little piece
power.
of the puzzle. Everybody has a little piece of the puzzle. And I'm seeing like we're learning every time we have a new guest on a little something more.
That's exactly it.
Absolutely.
Everybody has a piece of the puzzle, right? And once we get all those pieces together, do you remember the video I showed you with the aluminum covering that small coil?
Yeah.
We're going to have something to show on Friday, I think.
Oh, nice.
Yeah, because it definitely contains electrostatic charge. Huh. And I've seen some crazy stuff, so we'll show it on Friday.
If the universe had a real Avengers team, this would be it.
Yeah.
Or at least a precursor to it. Yeah, for sure.
We're getting there. We got a few more pieces to put in, that's for sure.
Yeah.
And then one of the biggest pieces is getting everybody in the same room to talk.
It's, you know what? It's really too bad we can't talk about that one subject that would get us kicked.
Yeah.
You know what I mean? Because I've done extensive research on that and how it connects to this tech.
We might be able to on other platforms, though, so we can look into having, specific discussions.
Other platforms are having their cojones stepped on now.
Yeah.
Right?
Like, how's Rumble looking? Because I know that they're a little less strict, but their whole thing is like, we're not gonna censor you like YouTube.
Well,
that's true.
We'll have to maybe just put it behind the paywall or something, but everybody can enjoy the content.
Yeah,
because that's a conversation that needs to happen. So
yeah,
it does. Yeah.
No, that's a good idea too. Yeah, we'll discuss it.
I mean,
my daughter intuitively, she's an artist, and she drew a picture of what it was I was shown in my dream that has to do with this tech and that very subject. I'll show it when we finally get a chance to be able to talk about it, because it's cool.
That's exciting. Yeah, that's cool.
It's really cool. But
I'm always interested in anything having to do with people having visions or dreams leading to where they are now or the path that they're on now,
Man, if I told you things from my past, they're hardly believable, and I lived them. You know what I mean? So yeah, when you believe that there's a power outside yourself that's greater than you and almost everyone else, I would say, or everyone else, you know what I mean? Things start showing up that you don't expect. And I'm telling you, I can tell you stories about my past and you go, what? That's impossible. But there's witnesses. So yeah. Dreams and visions, dude. I live them all the time.
Well, once you start living right, then everything around you changes.
Yep.
Like,
yeah,
it's hard to describe. You just kind of have to feel it. It's
everything you do ripples out into the universe.
Yeah, but I mean, it's deeper than that. It's I don't know. Like, everybody around you is not who you really think they are, and something changes. You know what I mean? As you talk to people.
Yep.
But you gotta have a clean slate in your head. You can't bring all that stuff forward. You gotta let it go.
Yep. And talking about this tech and where it's leading, it really sets some people off because their whole belief system is around what they own and the job that they have and the paper they wrote for the job that they have. Their ego is directly tied to that. And because they can't humble themselves thinking, you know what, I'm way more than just some stupid paper or some stupid job or the car I own or the house I own. You know what I mean? We're way more than that. And if people could think in that sense, I don't think we would try and be nasty to each other as we have in the past as a human race, right?
Well, you know what I like to say, Gerald, let's lead by example. Let's do that.
You should have seen me for the whole week before I wound this coil, right? I kept looking at it going, I shouldn't wind this coil. And it was just telling me the wrong signals every time I did it. I didn't know why. It just would, right? I'm going, well, it doesn't look right. This isn't right. Every time I turned it, it wasn't turning right. Every time that I would go around the nails, as you would call them, right? It'd be wrong. Every time I tried to turn something, it would cross something. Okay, and it'd be wrong. I have wire on my floor in my garage here, okay, that I've literally wound hundreds of these things already with that wire. And I keep reusing it because it's not right. You know what I mean?
Yeah.
The math doesn't work out. So let's put it this way. I've not only done it, I've measured the wire, I've checked it out, I've seen exactly how much is in it, and I know exactly the numbers that go along with it, okay? And I know it's not right. So every time I look at it, I go, okay, we had an absolute failure going on here.
You said it when you were doing the video. I was like, yeah, but you're just, yeah, you're so close, right?
No, because there was no outside coil form.
Yeah.
And
I know what you mean.
yeah, it's not one of those things you can actually see it, but you know it's there.
Yeah.
You know what I mean?
There's a form, and I've kept what I showed you guys tonight. I kept to the chest because wasn't going to tell anyone for a while, right? But I look at it like this. If somebody goes out, makes a system like this and patents it, makes it rich, good for you. As long as the tech gets out to people, don't shelve this crap, get it out there, right? And hey, you want to throw me a couple bucks? I love coffee.
That's right.
There you go. So, but I'd prefer, honestly, to get this tech out to everybody and then get paid to build the systems for people.
Well,
There's so many people could open businesses and it wouldn't make a lick of difference. We need to get 1 million businesses opened up doing this stuff.
Yeah, and we could stimulate local economies. That would be a very good thing. I love it. I love small business ideas.
I think one thing you may think about doing, and this is up to you, is just get people together and just wind one winding. You know what I mean? And then if everybody can figure it out, and we all do just a group thing, private thing, it doesn't have to be on air, and we'll just figure it out. And then you release it when you're ready. You know what I mean?
Yeah.
But then we release all of our coils at the same time and show the same experiment doing the same thing. You know what I mean?
I do. David
Yeah,
Chester's
the coil.
research had recently reached the same conclusion. I had reached this conclusion years ago, but like I said, I keep stuff to myself a little bit, and I probably shouldn't have, but it doesn't make a lick of difference because when it comes to academia, even though I have respect for those that are in it, because they work hard in it, when you're putting out something for your peers to review, I'm not an academic. So for me to put something out for the academics to review would be wrong just in the very sense that I'm not their peer and they're not mine, right?
Exactly. Yeah, that's
and there's nothing wrong with that. It just is what it is, right?
Yeah. It's just two different perspectives, you know?
Yeah.
And this is a quick update because I know I had a viewer who wanted me to contact Great Scott, a major YouTuber. And I did go on his Discord, which is the only, contact I was able to obtain. And I did share the rodent coil system. I was like, I got a rodent coil system working. I have a do-it-yourself guide. You guys can, try to debunk it if you want to. It's pretty cool. And this is like the fourth time this has happened. I just get laughed at. Fake science, blah blah blah. I tried. I knew it was gonna happen, but I said the information is there. If you want it, it's there, and I'm not gonna stick around. It's one thing if you want to ask me scientific questions, which was what I was excited for. Ask me the real questions, but don't just laugh at me and just say it's fake. That's
what? Those that laugh and say it's fake don't have the guts or the brains to do it themselves, and that's why they laugh, because they can't. Oh, I don't have the time. It's not worth it. Oh, I'm working on something else. My paper says, but my theory is, and it doesn't match yours. All that's a bunch of bullshit. We're only here to experiment and learn from that. And if you can do that, you've already won. Why? Because you learned something. These academics that sit there and they write their papers and they're like, my theory is correct. And if you don't have the right circumference of the right, I'm just messing around.
Yeah.
They don't like you. Well, fine, don't like me, but stay out of my shit. You know what I mean? Like, there's a lot of academics that will write papers, they'll denounce you, they'll laugh at you, but then they're sitting there watching, trying to steal your work, and then go write another paper about it, declaring it's theirs. So I don't take into account people that laugh at me. In fact, I love it.
That's
go
true.
ahead, laugh away. Prove me wrong, please. That's all I gotta say. Because if you prove me wrong, I'll be the first one to go, hey.
Yeah, what if I made a mistake?
Like,
Didn't know it, you know? I'd like to know.
You know how many people tell me I'm building Minecrafts wrong? Every day. Every day. Somebody's got to tell me a new way to build it.
There was something I had to ask you, Nathan, because I seen on Apex website, you know, they had like little thumbnails at the bottom of their website, and one of them was like a team supposedly got the Grabaflyer to work. Do you know which guest that was or how to get in contact with them?
Nope. There was rumor of it. Never saw any work.
Never saw anyone.
Nope.
No, because I was wondering like if we could like get in contact with somebody who got it to work. I don't know.
I don't need it.
Oh, I know. I'm just I was curious. Like, what happened with that? That was just something that came up, and nobody confirmed it.
I don't know. It sounded like it came from the inventor himself, and at that there was no visual proof of it, and that's the story I heard. But no.
So, okay, yeah, I was just curious.
Yeah.
Sorry, I'm just catching up on the comments, reading.
Yeah. I think it's funny sometimes because people go over there and they tell you how this thing works, right? But they never stop to listen to what I said. And I was telling you something for a reason. And and when you put everything that I said together all at once, then you start to see it. And even when I make a compilation video, people still aren't seeing it. They're still telling me the same idea that didn't work that I showed earlier. Or they're telling me all about ion wind when I already just told you and it was no, right? Or something else. And they don't understand how the thing gets amplified. And then they tell me that the disc is wrong. It's the wrong shape. And I always say this. If somebody did it and you see it, your job is to go back and do it the way they did it. Not the way you think you did it. Not what came into your head while you watched it. It's exactly how they did it. Find out what they found out. Then you can move forward. But do not move forward until you do. You continue to find out. This thing could be flying tomorrow. And you'll not know a single thing if you didn't listen. You're going to go back and watch it again and again and again. You still won't learn because you're still going to come up with a new idea every time I'm talking. I have somebody that consistently does it. And I can tell you right now, when you put something on a scale, I can make that scale drop 4 pounds in like 1 second. And you can't do nothing about it because you can't match it. You're going to get a gram. You're not going to get pounds. I'm going to make that sucker go crazy because I understand what I'm doing. That's kind of one of the things here. You know what I mean? It wasn't like I just woke up yesterday and learned it. I took some time, learned everything.
Well, because of what you learned, you taught me about temperature differential being a very key factor in the system that I'm running. I never would have even thought of running my lighter inside my coil and watching the voltage change. Apparently that's not supposed to happen. And it unifies the field theory, apparently.
Because they don't understand voltage the right way.
I would have to agree with that.
Because they want to calculate watts into joules and move on.
And that is correct, but it's not correct for this system.
No, it's not correct because the watt lies to you. It bounces between volts and amps constantly. And the wattage will continuously lie. That's
why it's called a watt. What?
You can calculate watts. That's fine if you want to know the power of your system at that very moment. Give me 2 seconds and I'll change it right in front of your face. Like Gerald said, let me put a lighter on there. I'm going to change your voltage and your amps right now.
Yeah, that's why I kind of get frustrated when people explain, oh, this is the wattage. No, I sometimes want to know like the voltage and the current, because that makes a difference. Like you said, not all volts are the same.
Well, if I'm running 1200 volts and I don't know how you calculate an amp or two, but my secondary will be showing up like 1200 volts. I'll run it through a bank of LEDs and capacitors and it reduces the voltage, but my LEDs are running at full brightness and it takes 94 volts per panel, 1 amp to run, and there's 4 panels on my little box that I use for testing. So could that be 4 amps, 1800 volts? I don't know, but if it is, that's a lot of power.
So
right?
Check this out. You also depends on what kind of light bulb you use. Gerald Moore always said it goes over, okay? So it goes around the circuits. It doesn't have to flow through them. If you have low enough amps, it goes right around it. And then it lights up the light bulb. Oh, look, they got a kitten.
Oh,
hold on. Everybody's going to want to see this, Gerald. Hold on.
I know.
Oh, there you go.
He's fast. He's very fast. Okay. So let me he's hopping now. Can you guys see him? You going to show your little face, buddy? You want to show your little face? Say hello. We call him Rocket because I wanted him to show his face because his face, he looks a lot like Rocket. Like almost identical. It's hilarious.
Nice.
All right. Sorry about that, guys. I got to shut the camera for just a second.
Yeah, not a problem. I got a cat that color, that dark gray.
Yep.
Yeah, I got one of the same color. It's so funny because we used to, like, when you go out of the room, you got to stop them from doing stuff, right? So that you can get out of the room. So you put the blanket over him, right? And then he pops out of the blanket. So you do it, and then now all he does is go hiding under the blanket. Like he tunnels under there and sits in the bed under the blanket every time.
My cat does the same too. In fact, she'll meow if I open up the blanket because she wants to sit there and hide.
Yeah, that's right.
It's funny how that works, eh?
Yeah.
Sorry, the kittens are all kind of running around right now, so I'm trying to move things around and stuff. So I apologize about no camera here.
Yeah, it's not a problem.
Electromagnetic kitty.
Now that would be funny.
You can only imagine what kind of lives they're going to have with Gerald in there doing experiments and these little kittens not knowing any better.
Yeah, watch them turn out to be 10 times the size as regular kittens. That might be a problem.
Like Maine Coons.
Yeah.
He's got a bunch of little baby tigers there with him.
A tiger? I'd love to have a tiger. Can't afford one, but I'd love to have one.
Oh, you're going to have a bunch of them now, a whole litter of them. You keep doing experiments in there.
I know. You got to be careful, right? Like, who knows what long-term effects this tech could have? Not that it would have any bad side effects. I haven't seen any at all, and I've been testing with it since 2008. So what is that, 16 years?
I can tell you.
Go ahead.
High voltage has a very bad effect on people. It makes my arthritis worse in my hands. It makes them real stiff. So,
see, I can't talk about anything further because I don't want to get in trouble.
No.
But you're right about that. But there's an opposite to that. Now we'll just leave it there.
Yep. We'll all figure it out sooner or later, apparently.
Exactly.
So funny. 9 cats. Somebody's got 9 cats. I got 4.
Right now I have 13 plus the 6 and the mother, so I have 20.
Nice.
Yeah, but they all, like, we find them homes, right? The 7 that we have, those kittens are all going to have homes, and 3 of them we're waiting for confirmation on homes, and we're holding 2 for somebody else right now. So
Nice.
it's what we do. Yeah, there's so many cats out there, nobody takes care of them. You have to. Somebody has to, right?
Yeah. Well, let's just say the neighborhood cats come right into my garage to get fed. They don't worry about me.
Yeah.
Well, I have a bunch of canned food on top of the dryer. I just open a new one and give it to them every morning. So
yeah, I got a box sitting over there. I understand. Yeah, totally.
So funny. I told my wife every week it seemed like there was something new showing up, some kind of new animal, right?
Yeah.
I said, if I ever go to build a boat, please know that we're going to be in a flood, because I've had rabbits, I have raccoons, I have snakes, I have all kinds of lizards, and that's just the normal stuff. And then I have tarantulas come by, and then we start getting other bigger animals, right? I start to get some coyotes over here. Then, and maybe it's just one attracts another, I don't know, but everything keeps showing up at my house. Not everyone else's house. They just show up at mine.
I wonder if it's the high voltage.
I don't know. Maybe it's the frequency it runs at. Who knows?
Well, it makes me wonder. There's certain things you can't talk about, otherwise they'll cancel our butt. But when it comes to frequency, it does a lot of strange things.
Yeah.
Yeah. Like I said, I have the list from Rife, but before I even had that, I've done experiments with different frequencies that, I don't know, just you see weird anomalies. Let's just put it to you that way. That's the safest way of putting it.
Yep.
Yeah.
Sometimes you go out and you just run things wrong and you just walk away.
Yeah.
That was not the way to do it. I'm leaving now.
Yeah.
I've had many of those days working with different things in there, especially when I was trying to map out the center plate. Oh my God. It was the worst, because it's all based on the amount of speed the motors get.
Yeah.
And if you don't get them right, man, it's just bad.
Yeah, because nothing's going to match. It's kind of, the way that gravel flyer, man, I got some expertise in certain things, but I couldn't cut my teeth on that one. No clue whatsoever. I do now from learning from you. But in the beginning, I was just seeing people spin magnets and, right? Not seeing too much else.
Yeah, let me show you. I came up with a solid state version of it, right?
Mm-hmm.
So this is kind of the gist of it. I'll show you both versions here.
I like genetic Jabber's joke, but I don't want to put it up.
So basically, you just see the inside of it, right?
Yeah.
And see my cursor on there. If you follow this winding, right?
Yeah.
It'll have a coil on top. There's a coil on the bottom. There's a coil in the center. There's a Tesla coil dead in the center.
Oh, that's what that is.
Yeah, and there's 2 plates on the top and bottom. Now, all it is based on a different experiment that I have. Once this plate gets activated to this plate, it creates pressure. So you want to talk about several pounds of pressure going in one direction in a very short time? That's how you do it. So you would think it would cancel out, but it doesn't. Depending on the material you use, it'll make it go up or it'll go down to the bottom coil, depending on how you do it, right?
Yep.
Now, there's a chamber on the inside there so that you can contain your static electricity. The Tesla coil flows around the craft, so then you'll be able to put the field around it like you're supposed to. So this was the first one I was looking at, and
It's an interesting concept.
yeah, it's just different, huh?
Yeah. Different is good. That's what we need. We need different.
So
Someone said it looks like the flux liner. Doesn't it share similar methods of operation? Because the flux liner is outlined with like a layer or an outline of capacitors on the outer array, an array of capacitors on the outer edge.
Well, there's a way to create capacitance without
having
creating direct capacitance to a capacitor.
Yep.
Right. That's what I thought. Yeah, it's utilizing a similar method.
Kind of like the way OdySee Car did with the U-Tron.
No, that's cool.
Yeah, so it's just a single step, and I have it in pieces right now.
Nice.
So we'll find out exactly what it does. I wanted to widen some coils first so that I can figure out these two big plates here before I move on, because I need something that's really going to push it. You know what I mean? And it's really got to pull that number up, because I've already blown past the amount of weight that goes into the craft. So that's not a problem.
Mm-hmm.
It's getting the fields right and getting the bubble to bounce. So it's a bounce. It's like dribbling a basketball. If you don't do that.
Yeah. You're right. It is a bounce. I'm trying to figure out a way of, you've seen how the coil created the bubble above the magnet and then it stayed there, right?
Yeah.
I think I figured out a mechanism. I'm trying to build the circuit right now to make it keep going without the magnet. It just needs that first initial magnetic pump. Once it's got it and that bubble's created, it'll sit there. Then you can walk it up from there. And I'm working on a circuit right now, but a little difficult. We'll see.
Well, it's because I'll say this. The bubble around the coil does not build until you're achieved the first bubble.
Oh,
it cannot achieve itself on the ground.
Yeah. Speaking of which, the aluminum encasing, the bell that you've seen, that might actually come into play as a factor for what we just discussed, because we'll get into it, but it has to do with the circuit and the bubble and the ground and a virtual ground and where you move that energy to and how you make it flow in the coil, around the coil, and on the skin of the system itself.
It's so funny. If I were to tell you a bubble maybe 6 months ago, you know what I mean?
Yeah, I wouldn't have got it.
Yeah, you wouldn't have believed me at all either.
Wouldn't have got it. But I understand what it's doing. It's compressing a bubble above the magnet, and then the second bubble that it creates kind of compresses into the first one almost like a sandwich, and then it can hop from there. Right? That's what I see now.
It's when I showed these tubes earlier, okay? These little tubes right here.
Yeah.
When you see them in person, you'll understand 1,000 times better. When you see the bubble, okay, it creates it looks like this.
Yeah.
But then right next to it is creating another one. And right next to that, it's creating another one, right?
Yeah.
The voltage works like that. It's not necessarily a straight line. So
I know what you mean by that. Yeah.
In these, you can start to see it up close and in person that there's a bunch of lines in there, right? And it shows up in like tube lights when you run certain things. You'll see little dots in there. Now, in person, you don't see the dots. You see the brightness of the bulb. But on film, you see the dots. Okay? Well, imagine taking your film and speeding it up and slowing it down and seeing what it does, right?
Oh yeah.
You'll start to see all the imperfections in there and how it's actually flowing. It changes how you see it. Then you can start manipulating that field once you know it's there.
Yep. Well, the video I showed you earlier where it shows the neon pulsing, I don't have the right video keyed up, so I can't show it to you. But what I did was, as that was pulsing, I slowed the video down because it turns purple. And I thought, okay, that's kind of neat. So I slowed it down and I repeated the experiment, and it almost looks like ball lightning inside there. But I can't slow it down enough to see that. You just see the purple and the pink, and it almost looks spherical, and it's gone. So interesting.
That's right.
Yeah. So, yeah, I'm very excited as to the coming days and what's being built and what's going to be shared. Because although the coil that I showed you to do, the next level is going to be adding 3-dimensional 1/4-inch copper tubing intertwined bifilarly. It's not even a word, but yeah.
Gerald, did you see
So-
the new fireball?
Yeah, I did. It's beautiful, by the way.
It needs a little straightening, but it's gonna be real nice when I redo this wire. It was a foot too short, so I was like, but
sucks.
I've got enough wire. I can do it again.
Hi,
I like-
Lulu. Sorry.
Hey, Lulu.
Lulu. It's Lulu. I love that name. You have the best name, Lulu. Seriously. I love that. But yeah, so this next coil I'm building it has to do with water and gases and heat and cold, and we're getting into some crazy stuff because of what you taught me there. So I'm gonna give you kudos in that one for sure, by far.
Oh, man. Well, you should see my conversation sometimes in Merkaba.
No doubt.
But
No doubt.
go into all kinds of different stuff, man. So, and everything, it's so funny because it all comes back around the same thing. If you understand frequency, you understand resonance, then it translates right into that next project. So you're building a coil, he's building a device like that, and then Ben's building a coil. Now I'm building a coil. Sean just printed out his first rodent coil, so he's going to be building that, Ben. So, and then Ian's got all kinds of coils. So
Ian's hard to keep up with. Are you kidding? I'm just trying to stay level with the guy.
Hopefully, Sean will be joining us for our workshop on Sunday. We'll be going over everything from how to wind, twist, and make the coil and configure it, solder the ends and all that good stuff. We're going to walk you through every single process.
Well, I hope you have your test down on how they're done, because Sean likes a very particular way to do it. So
it's all gonna be well, most of it's gonna be pre-recorded, and then as that's going on, I'll also be demoing. Hopefully, I'll have that orange one up and running by then.
yeah,
That's the plan, at least.
Gerald, we all got to get that circuit from you for the what was it, the amplifier, because
Yes.
there's a lot of people who run the amplifier and they really want that circuit.
And you know what? I built it out of something I don't normally build it, and the testing, I didn't like the way it showed up. I usually use it's an EL13009 MOSFET.
Oh, you're kidding me.
No,
I just looked that thing up today.
that thing is an amazing little MOSFET. It works perfect for this. But I blew my last one, so I made it out of a tip 35C, and it didn't work out quite the way I wanted. So I ordered some 13009s, and when I get those, it should be here for next Wednesday. So I apologize to everybody. My bad. I didn't have the circuit that ready like I was supposed to, but it will be ready for next Wednesday.
So you can
Nice.
run a flyback with one of those.
Yeah, I can't see why I wouldn't.
Well, that's what it was for. That's what I was looking up today.
For a flyback. Well, I thought it was for the stereo, for the amplifier.
No. That's what you're using it for, right? I'm saying I looked up the same MOSFET today because it was for that. It was in a different reason. So,
Right.
Trying to rework my high voltage a little bit.
Yeah, I hear you there. Well, that particular transistor or MOSFET, that was what I used when I very first saw ball lightning for the first time in my neon.
Nice. Yeah, I think isn't that a transistor?
I don't know I think it's a MOSFET, but it might be a transistor. You could be right on that. You could. I know it fires super fast. Like I blew up a neon because I put too much power through it. And I've never seen a neon blow up before. Man, they're like shotgun shells. Boom! They're loud. So, yeah, I don't know. That's interesting.
Wouldn't be this show if we didn't blow something up once in a while. That's for sure.
Yeah, I should set up my series of electrolytic capacitors with the coil again. I used to do that for fun. I'd hit the power and it'd be like, bang, 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 bang. My wife hated it. We should show that. Not just, yeah, we should.
Absolutely should show it.
Was there any questions? I know Ian had a question about longitudinal waves.
You see it?
I think this was it here. Would a transducer do the job? Yes, it didn't work in my big coil. That doesn't mean it's not going to work. I may have had it in the wrong spot in my circuit. I do have a circuit for that. It's the one that I haven't shared yet. It's that one's coming, but I don't want to share that one until Nathan builds his first coil on the right mark, because that circuit is like the final icing on the cake. That's the one that I had problems with, not because the circuit itself, but because it was creating so much power in my system. I didn't know what to do with it. Like I couldn't do anything with it. I couldn't step it down. I couldn't, nothing. We're talking 2,000, 2,500 volts and up, and I was blowing meters, and that's the one I blew the oscilloscope with. So,
Nice.
yeah, it's. I will be releasing that, Ian, but I promised Nathan that I'm going to wait till he gets his coil done first.
So, can you draw up before the next live that circuit for the amplifier?
Yes,
Just with all the parts, so that we can all order it.
Yep.
Or if you just have a parts list, we can all get started on ordering it.
Yeah, that's something that would be useful, because I want to start following along eventually with these Wednesday streams, in your builds.
Yeah, I do.
Once layout season happens, I'll have a little bit more time to do that, so
Yeah,
that'll be fun.
get the parts while the money's running, huh?
Yeah.
Yeah.
Exactly. Yeah. But no, that's something that I'm interested in, because I like learning more about building circuits, and I have a whole bunch of circuit part, like electronic parts and Arduino parts. I just don't have the transistor and the MOSFET or whatever.
Yeah, that's what I have to do, is get the MOSFETs, or the MJ. It's an MJE 13009. That's what it is. And it's
Different altogether.
What's that?
I said that's different altogether.
Is it? Well, which one was it? I said an E 13009, right?
EL. That's a transistor.
Right. Yeah, this one's an MJE 13009. So that, I believe, is a MOSFET. You also need a Schottky diode, a 270 ohm ceramic resistor, and 2 4-ohm ceramic resistors as well. That's the parts list.
Would I be able to use resistors in series to produce like 270, for instance?
Yeah, sure. Why not? They were 10 watts ceramic resistors, I believe.
10 watt. I might have to order some of
Check.
those. I don't think there's any in my kit.
I could check. They might be 15s, actually.
That looks like I'll be over at Amazon later tonight buying parts. Get them sent in and start building. Hey, Ben, do you know how to write code for the Arduino?
No, I do not. I mean, I know very, very basic stuff, but not anything for practical use. No.
Yeah. So
What I do is I use Chat AI. Sometimes that helps.
what I used here was I got a 4 ohm and I got 2.7 ohms, and they're all 5 watt ceramic resistors.
Mhm.
Okay, I don't know if you can see that. And then I used a 15 watt 270 ohm ceramic resistor.
I've never seen a ceramic resistor before. That's cool.
Yeah, they come out of old television sets, but you can order them, right? They
Kind
come
of
in
look
very-
like a capacitor a little bit.
little bit, but it's not though.
Mm-hmm.
Yeah.
That's cool.
And they smell really nice when they heat up. It's weird. They smell like flowers.
Really?
Yeah.
That's cool.
I've blown a bunch of them.
Then you know. Yeah, they
I
smell.
wonder what's in them to make them smell like
When
that.
you start hooking up your TV as high voltage instead of a TV, you start to fry things on the board.
Yeah.
I guess it gives a new meaning to flower power.
Oh, that's good.
Nice.
This has been awesome, guys. I'm gonna have to bail out. I got some stuff I got to do before morning. And,
Yeah, I
Yeah,
got work in
it's
the morning.
3.5 hours. So
yeah. I'm sorry about the circuits and coming late. I had car trouble and I couldn't get ready for the show. So, don't string me up. But yeah, next Wednesday I'll have that circuit. We'll do it live. I'll solder it live.
nice.
Yeah, that way it's a little easier for you to understand. And there was another circuit that I had to show for you guys this Wednesday. It's in my notes. I'll make sure it's shown next Wednesday. So I will be ready for next Wednesday's show. Fully. So sorry, Nathan. Sorry, everybody.
It's all right. It's like I told Ben, pre-tape it, and then
No,
Ben
that's a good idea.
narrate it.
Yeah, that's one of the best pieces of advice I ever got. Pre-tape it. Because that gives me it gives me the ability to control, like, because I don't know what's gonna happen if I do it live. People could be walking by and somebody could get into a fight. I don't know.
Yeah,
That's true.
Right. So there's unpredictable element that you eliminate, and then also, it frees you up to actually interact with the class and answer questions and demo something.
I like answering questions.
let me tell you that live stream we did with the Tesla coils the first time.
Mhm.
I literally finished that 10 minutes before we went on air. It wasn't working. It wasn't working.
Oh,
And
boy.
I said, no, one last shot. I got this.
Yeah.
Immediately started working. We got 10 or 11-inch sparks.
That's awesome.
Nice.
So
It was like that countdown moment where it was like, you see the countdown timer.
well, because everything else left your head. Look at the little kittens.
Oh,
Those are all like from the street. The mom brought them in and they've been here ever since.
some gangsta kitties.
Yeah.
Nice.
Sorry, guys. Had to do that.
It's all right.
Everybody loves kittens, right?
Yeah.
Yeah.
Who doesn't love kitties?
Dogs.
Yes, they finally they saw the kitties.
Yeah, I know. The past couple shows, all they hear is that's what's meowing.
Everybody's remarking about the cats. It's so funny.
Yes, everybody, it's not a pre-recorded meow track. That is a live meow.
Yeah, they're all over my feet and they're running back and forth all the time.
Nice.
Yeah. Okay, we get that you're there. Thank you for announcing.
All right, guys. Thank you very much for joining us today. On Monday, we have our normal live. So Ben's got a special guest. Go ahead, Ben.
So we have Michael Morell coming on for an hour presenting his rodent coil, PoE coil. So that's very exciting. I'm really excited. I have a lot of questions, and he's shown me a couple of pictures and videos, and it's going to be really exciting.
Nice. I look forward to that.
I'm going to be there on Monday.
Well, if I'm invited, I'll be there.
Sure, you're invited.
Yeah.
Always there on Monday.
I love up in the corner. Your little symbol with the 5 or 6 channels in it.
Yeah,
it's
that's
like,
neat.
Yeah, it's like the stones from X-Men, right? Or not X-Men?
Or the Infinity Stones.
Infinity Stones. Yeah, there you go.
I had some time. It was funny because I wanted to see how things go when you change all the different fronts of the videos, right? All the thumbnails. So I changed them, all the different ones for everybody. And then I went ahead and I was messing around and building things, and because I'm trying to learn the program in order to get my thumbnails to look better. You know what I mean?
Yeah.
Because they're kind of eye distracting, and I just wanted to go with little less is more.
Absolutely. I like it. I think it's awesome.
I think it's cool. Yeah.
All right, this cat's going to keep meowing all night, guys. I'm going to have to bail. So you guys have a good night, and we'll see you on Friday.
Thank you, everybody. I really appreciate you showing up.
Yeah, thanks, Nathan. Thanks, Gerald.
Thanks, everyone.
Have a good night, guys.